we go.
Always something.
I know. All right, here comes the music.
Does that sound okay?
Oh, yeah.
Okay.
Be with you in a couple minutes, folks. Hello, everybody. Welcome to SkyTour LiveStream. This wonderful, October 27th, 2021. And we're going to be trolling some riffs tonight. What? Riffs, R-A-F-T-S. Daryl is here with me. Hi, Daryl.
Hello, Mark. Hello, everybody.
And we will be having some fun. I'm doing some final setup here. As you can see, I had to run upstairs and take care of something that was pressing upstairs, and it's no longer pressing. So we're in good shape now.
He had to go to the bathroom.
No, actually, I did not. I honestly did not, but that would have been a good excuse and something you would not say to people, right?
Yeah, well,
typically. Yeah.
Okay.
I actually...
Shame on me.
No, not at all. Not at all. I just gotta maneuver things into a position where we can explore them fully.
Well, I got the trash taken out, so I'm good there.
All right. Good, man. All
We
right.
have to use bear-proof containers now, and
Oh,
I used to take it out early on Thursday mornings, but now with the container, I have to roll it out late on Wednesday nights, and
gotcha.
don't know how that we may be here tonight, so I took it out early.
We're not going to be here for 5 hours. That was last night. We won't be here for 5 hours tonight. Although, yeah, there really is some really cool stuff out there, so that's possible.
Yeah.
All right, well, I remembered the 1,000 milliseconds from the time I did it before. Let's see if it remembered the... Yes. Okay, I think we're all set. The camera remembered all the things that I wanted it to remember, Daryl. That's good. How about the cooler? And it remembered to turn on the cooler. Yes, all right. Very good. So, folks, just want to let you know tonight's stream was sponsored by FX Models, a visual effects and model making company, and they have all kinds of crater and well, they're actually 3D printed craters, and they have a 3D printed moon. If it sounds familiar, it's because it is my company. I'm self-sponsoring tonight. It's a start. You know, we're gonna be doing other things, and we have the possibility of other sponsors potentially down the line. But I want to thank you guys for your support. I've been having a great time doing all this with you, and hopefully tonight we'll get to see some really cool things. I'm really expecting that we will. I hope you enjoyed last night too, because last night we actually saw some really cool things as well. Yeah, you know, I actually didn't put up a post in Facebook about this, but I probably should have. Okay, that's a problem. You know, I should have put up a post to show the things we took, but they are up on the server in case you want to go check them out, up on our OneDrive public server. So enjoy that if you will. I'm gonna just point out real quick for those who may not be familiar. This is our camera control system over here on the right side. It's a fly out menu. All of our camera controls are here. This is the main screen, which we will maximize during our broadcast. This is the telescope control section up there. This is the telescope right here. You can see it right there. Okay, and that's in the building. The roof is now open and the telescope is active and running. And this right here is the telescope control menu. So we can actually look into the telescope to see what it's doing. For now, while the telescope is cooling down, its sensor is being brought down to -10 Celsius. I'm going to run this up into the sky, and you'll see stars going by there, and then we'll just have some stars to look at for a few minutes while we cool down. We're at -5.8 Celsius. You can see that if you look right over there. Okay, you can see it right there. -5.8 right here. Now it's at right there, -7. -7.3. So we actually have sensor cooling very well, and we also have a focus system that we run in here, and I'm going to bring that up too. It's not up yet, and the focus is very important. I do want to say hi to Tara. Hi, Tara. And I want to say hi to PG, who is here, and Linda Marie. How are you? Nice to see you. W, what's going on? And Vera Lucia Campos from Brasilia. ¿Cómo está usted, Senora Campos? It's so nice to see you. Welcome to SkyTour LiveStream. And we have several other people that are here. We have XPFTP, who's here with us tonight. And we have Mark Hartzman. I just talked to Mark. He's writing some really cool books. Mark, in a message here, why don't you put in your books, okay? And even if you have a website, I know you can't do a link yet, but just type out the link so people can go check it out, all right? Because I'd like to let you plug your stuff here, all right? As the course of the night goes on, we'll get more people. It'll come and go, and we'll be getting more people later on as well. And Bonnie Anahata 77, nice to see you. And well, I don't see you. I mean, nice to see you here. And Cypher 2 Productions is here. Cypher is great. He does Cypher, I don't know if you're male or female. I'm sorry. So I apologize. But Cypher will put up links for us sometimes, and it's very kind of him to do that because sometimes I don't remember to do that. And Mike C, welcome. Thank you for coming out. Trick or treat, Mike. Yep. So we're having a good time. And we're going to get off and run here. And Daisy and Zoe are here as well. Very nice to see you. And you're on vacation in Georgia? Wow, that's cool. And you thought to come see us? You know, I'm really humbled. Thank you. That's really nice. Thank you for including us in your day. Well, actually, your evening. So the telescope is working well. We actually have a system in place, which I told you in the past, that here we just have a field of stars. We can actually just have the telescope identify exactly where it's looking, and it will know exactly where it is just by looking at the field of stars. And that's a really cool feature that we added. Little by little, the telescope is becoming a lot more robust. And so we have room in this building for 2 more telescopes. We're going to be getting at least one more that's more close up. And we may be getting another one that's extremely wide angle. I'm thinking actually, I was thinking about this, Daryl. Maybe I'm going to get a wide field camera, just a camera, just to do wide field views of the Milky Way, in the sky. Cool. Yeah, and I'm also thinking about a camera that will go on the finder scope of this telescope right here, and allow us to see what the finder sees, so we can see it from that point of view as well. That was more important, though, when we didn't know where the telescope was looking, and I had to use the finder. Now that we have this ability to solve for the pattern of stars, that's almost an unnecessary thing. Our temperature is -10, so we are at observational temperature. The telescope is ready to go. So why don't we go check out where we're looking in the sky. This is our live planetarium. You can see that we're up there. We're actually near Saturn, but the thing is, this telescope is not a planetary or lunar telescope, at least not now. I'll be out there, let's see, today's the 27th. I'm going to be out there in just a few days, and I'll be out into the building, and I'm going to make changes to the telescope so that we'll be able to observe Jupiter, Saturn, and the moon with impunity, and it'll be just beautiful.
You are?
Yes, I'm going to be out on the 5th.
Oh, well, I meant you're changing the telescope back to FA?
Nope. No. I mean, I'm going to collimate it so that we'll be able to actually see these objects with much sharper focus than we have now. Okay. And there's Venus down there on the western horizon. It's actually quite low. It's nothing that we could observe right now. If we look at Venus, we'll notice that it is at a height. Bringing up the, let me bring up the grid line here so you can see it. In case the grid doesn't want to work. So why is that? I don't know. But I can tell you that its altitude is actually only about 12 degrees above the horizon, so that's not good.
Yeah, really bright though.
It's very bright. Yep.
Brightest thing in the sky after the sun and the moon.
Mm-hmm. Yep, that's right. Now the sun is obviously quite a lot brighter than the moon. Okay, thousands and thousands of times brighter, of course. So I don't know exactly whether I'll ever do solar viewing with the telescope. I've been thinking about it, but I'm not sure I'm going to do it.
That's a very specialized field. You can see some really cool stuff, and we're past solar minimum, and looks like we're building up rapidly back toward. There's lots of activity on the sun right now. There's a sunspot just coming around the eastern edge of the sun.
Yeah, it's pretty wild, yeah.
Yeah, and it's just going off like crazy. Solar flares constantly.
Yeah. Really, it's quite promising if you're a solar viewer, And for those that I just want to say welcome to SkyTour LiveStream. Okay, it's a live deep sky observatory here for you, and that was a satellite that just went through. Let's see. Oh, W. He goes to bed early. He got a long day tomorrow. Well, you know what? I'm just pleased that you took a bit of time to come check us out. And hey, it's 2 days in a row. That's right. And it was just the other week we did 4 days in a row. Yesterday's stream was 5 hours long, dude. You were long asleep by the time we finished. There was just so much to look at, right, Daryl? I mean, we're having a ball looking at stuff.
Oh yeah.
Oh, huh.
Saw lots of new neat things up in Cepheus.
That's right.
And hopefully we might go back. I have a few more picked out in Cepheus, and
okay.
We were thinking of trying to explore the Great Rift in the Milky Way that runs from. There's a Great Rift right there.
Yeah.
Kind of runs from Scutum up to Cygnus.
Well, let's go up there and check it out. We'll start by going to this binary cluster. I'm going to tell the telescope to go there. Oh, Farva, man, thank you. It's so good to see you again. Well, the incoming debris field. Actually, just to talk about that, I think your name is Sean, right? Just to let you know, that debris field that they're talking about is nothing for us to worry about. And when you say a debris field, we actually have lots of space debris that hits us all the time, every day. We get many hundreds of thousands of tons a year of stuff accumulating on us, So as far as it doing any damage to us, it certainly wouldn't if it actually was a real debris field, but it's not. There's actually not a debris field in particular that's actually heading for us, so to speak. We need to be more concerned about asteroids that might be heading our way, okay? And that's something that we need to worry about. And that's why there's programs called the Centauri program that is used to actually determine whether there are asteroids on deadly collision courses with us. And I think that's very important as well to consider.
Oh, yeah.
Yeah. So here's the possible binary cluster we're talking about. This here, you see a little cluster here, you see a little cluster here. But this is right near what is called the Great Rift. And if we go back to our view here of the sky, we are here. And we'll just zoom into it right here. This is the Great Rift, and it's going to be the start of our explorations tonight. This red box that I'm bringing up, this represents the size of the field of our telescope. It's 2 degrees across and 1.5 degrees tall. That is, okay, the moon is half a degree, so it's 4 full moons across. And then it's 1.5 degrees. Actually, it's 1.28, but don't worry. 1 degree, 28 minutes. 1 degree, 30 minutes is a degree and a half, because there's 60 minutes in a degree. So the moon is 30 minutes across. Well, Drops of Jupiter. That's right. Drops of Jupiter was a great song by Coldplay, if I don't miss my guess. And that she's back in the atmosphere, drops of Jupiter in her hair. Hey, yeah, I love that song. Love that song. Very nice. Thank you, Farva, once again. That's awesome. It's good to see you. So here we are, and the Great Rift is actually over here on the right side. I'm not sure. Should we just go to the Rift and just image that?
Yeah, sure.
Let's find out what there is over here. See
why they call that one little area the Great Rift.
I mean, it's
Great Rift is huge.
It is.
When you see images of other spiral galaxies, you'll see the dark lanes and the spiral arms.
Yeah.
And that's what the Great Rift is we see in our own Milky Way. It's
that's right.
A huge dark band kind of splitting the Milky Way into.
Yeah. So what I'm going to do, Daryl, is I'm going to do this. I'm going to take us to a point where we're actually going at just about, let's see, half a degree per second. I'm going to drop us down. You'll watch us move. You'll see this moving. And you'll actually see this moving here. Hey, Donald, thank you. Rick Wakeman, there you go. Holst the Planets. Absolutely stunning. I actually used the planets as backdrop for talks I've done. It's really, really cool. We're going to come down here. I love Holst the Planets.
I like Rick Wakeman.
I like Rick Wakeman too, yeah.
Yeah, I was always a big fan of his Six Wives of Henry VIII.
Yep. Absolutely. Fantastic.
Really unique back in the day.
Fantastic guy. Yeah. All right, let's just go.
Keyboardistry, yes, by the way.
What's that?
Rick Wakeman is keyboardistry, yes, by the way.
Yeah, I actually saw him in a tribute. He had a tribute that he was part of, and I watched him in it. Very good. All right, we're going to go to here, this location, and we're going to try to image this location. If I come back to our regular full-size screen, you'll see there's a lot going on here, and there's some interesting missing stars over here. Let's find out if it's actually dark nebula that we're looking at, or we're looking at just an absence of stars. It's all part of the interesting program trying to figure this out. So we're going to take our initial settings and we're going to go to 25 seconds. We don't have a moon tonight, not for a while. And we're going to, this, by the way, this is this over here, you can see, that's our histogram. That basically is the data. These curves, red, green, and blue, these are the curves that are recording data on the sensor. And this line represents us looking, how much of it we're intercepting. If I undo this, you'll watch the line go straight and you'll see there's a lot less data. That's because now we're not intercepting the main brunt of the curve here that you see. We're only if you look at my cursor, we're only intercepting this little tiny area down here. But if I bring this over and I start moving it over, okay, you'll see that we're intercepting more in this, and the image gets brighter and brighter and brighter, see? So we're taking on more and more and more. But what we're going to do is we're actually going to undo this, and we're going to go to our live stack. We're taking a 25-second photo. And now what we're going to do is just sit back and watch it happen. But let's go to full screen, shall we? And watch how it comes in. And depending on how it comes in, we might want to change it a little bit, but we'll see. I can see we're going to have some really cool stuff over here. All right, so we want to do some processing here. All right, let's process this a little bit. Get the curves aligned better. That's more like it. Okay. Now, initially, things look pretty terrible, but then they get better and better as time goes on because the noise is alleviated by stacking multiple images together, which is just what we're doing right now. And this is an interesting feature right here, Daryl. Look at that. See that?
Uh-huh.
It looks like a perfectly round area with a big star in the middle, and it almost looks like propeller blades spinning like a nozzle, doesn't it? Now that is a line of sight oddity. It's not a real thing, but your mind sees this and thinks symmetry and makes it into a round object. It's really not round. If you notice, it's actually not a round thing. It's got a different shape. Yes, so many stars compared to the dark area. That's right, Tara. Yeah. Video killed a radio star. I saw that the first time it was broadcast on MTV. The very first time I was there for that. I actually listened to it. Video killed a radio star. I watched that MTV video back when it, like I said, when it first ever aired. That's the only time I ever knew about who the Buggles were, and that's the only hit I ever heard of theirs. Wow. That's pretty cool. Yeah, concert in the round. Everybody had a good seat.
Yeah.
Well, this is interesting. So, actually, we're zoomed in a little bit. Let me zoom out, because if we go to look at more of the field that's available to us, check it out. See, that's how much more is available to us. Wow, that's cool. Marianne Robb will not be in chat tonight because she is on her way to Las Vegas, where she's going to be at a police conference for the next few days.
For her.
That's right,
She's sure been
XPFTP.
getting aroused as she retired.
I know, right? She's more busy than when she was a police officer. XPFTP, yes, it was the very first video that MTV played, and I actually watched that video the very first time it came out. It was crazy. Yeah. Red and blue stars near the top left, Tara says. Yes, that's right. I see red stars here and blue stars. The red stars are probably either in the dark nebula that is back there, and they're reddened by the nebula dust, or they're actually red dwarfs, which is, in this case, probably more likely for that. Probably more likely for that.
I know when we talk about seeing dark nebulae in general, they're typically in front of background objects, and it cuts off the view.
Yeah.
Is the same thing going on with the Great Rift there on the right? I mean, is it blocking the view behind it?
It may
What
very
we're
well,
what we're
be.
seeing on the left is, like millions and millions of stars.
Yeah, it may very well be. May well be. I don't know for sure because I'm not sure if that's a dark nebula. Then yes, but
Yeah.
I'm not sure if it is a dark nebula. And just so you know, what we're actually in the Great Rift in the Milky Way, exploring the star fields of that Great Rift. Just so you know. So now you have an idea of what we're doing. That's a new feature, adding a little thing to tell you where we are. I mean, how silly, right? I mean, it seems like a very simple thing to do. Why didn't I think of it? I don't know. It had to come. Marianne actually suggested that. All right, so this is neat. Let's see how many we stacked of these. Probably like 10. Yeah, we got 10 stacked. We're going to pause this right now and move on to the next one. All right, but I will save it anyway because I want to have you guys have the ability to go capture and take any of these things you like. All right, and now we will save it just like we see it. All right. Okay, and now we'll clear this and go to a different spot in this amazing galaxy of ours. And to do that, we come back here and go back to our what I call finder scope mode. Basically, we just do 1 second exposures that are actually very brightly processed. So that's too bright. So we see what's going on. So there we go. All right, so now let's go to some other rift fields and check out where else we can go. Now, so we are in an area of the Great Rift. I'll tell you one thing. It might be cool, Daryl, to come down here a little bit. I wonder if we can explore this location. We can, no doubt about it.
Okay.
Yeah, I'm just waiting for the telescope to come back.
I just closed all my windows accidentally.
Uh-oh.
Darn it. I had a list of stuff for tonight. I can get it back. It may take a while.
All right. Well, me too. I have an issue here. The telescope's not responding to me right now, so I'm going to... Oh, I see what it is. Okay. We will be fine. I just have to get out of my Access program. It's got a problem. So, oh, why is it showing offline? That's bad. That is not good.
Did you remember to open APT first tonight?
Yeah, everything was done properly. Oh, brother. This could be a problem. I do not know why this happened. All right, this can't happen. This is... Oh, it's back. Okay, so let's find out if the telescope rebooted or something, or if this functionality had just gone down. Let's find out. Now it's offline again. What the heck? Ugh. I know, Tara. Oh, no.
Bummer.
Yeah, now it's offline again. Hang on. I'm going to try this again. Why? It was online then offline. This really stops you cold, doesn't it? All right, let's try a different tact. Let's log into the System to get me to the remote system. Let's see what's going on here. It says it's offline. How come? I do not know why. Big bummer. Telescope's open and running and pointing up into the sky. Luckily, there's no weather that's occurring.
Might you have lost your internet out there?
I can tell you right now, actually. Let me go check out whether I have lost the internet. Well, it says it's online, so what might be offline is the I might have had the IP address stolen again by other systems out there in the desert. Oh, wait a minute. Okay. Okay, the camera's not coming up. The off. It's outside the telescope. The that camera's not coming up. And now it shows that it's active again. Let's find out. Now it says it's authenticating. And we're back. And look, it's like we never went anywhere. I don't know what that was. But we're here. That's all that matters. Welcome back, folks. Little delay. Let's hope it doesn't happen again. All right. What do you say we try... Want to try this little area right here? Near the Phantom Streak Nebula? Alright, we're going to tell it to go there. First things first, though, I'm going to drop us into the mode where I can watch the telescope. Whoa, what's this? What's the point craft doing up? I don't want point craft up. Oh, we actually had a weird thing happen. Okay. Well, communications was reestablished. Everything is fine, so I have a feeling we're good. Alright, let me just move this over. This song is really funny because this is the song that I sing that periodic table of the elements to. You know, there's hydrogen and helium and lithium, beryllium, carbon atoms everywhere, boron carbon everywhere, and nitrogen all through the air, oxygen so you can breathe, and fluorine for your pretty teeth, etc., etc., etc. It's not my song. It's actually the periodic table song that another group made. It's really quite good. Okay, let's go.
You should practice more often, Mark.
I don't want to practice in front of all of you guys because that would be kind of bad, right?
Often in a field.
Ah! Well spoken, sir.
It's a very old joke.
Yeah. You should practice more often. Where? Off in the field. I don't get it. Yeah, I do. Yes, I do. All right, so let's go to the Phantom Streak. So we're going to just use that as a target and then tell it to go. Ready? Go. Now the telescope should just be going to it. Okay. And it's going to use a star nearby. I can see, so I can use this star right here. That's a streak right there. Look at that. That's something weird. That's probably some dark nebula there, yes? Mm-hmm. Yeah. So we're going to center this star. What is... Oh, there's a satellite going through.
There's a streak there.
Yeah, just keep in mind, folks, you're going to see satellites go through to the tune of possibly, 10, 20, 30. Because Daryl and I saw satellites go through here quite often when we're looking at it. Okay, we are centering on Ptolemaic Prior. Are we? I think we're actually going now to this location already. Oh, look at that. This is going to be kind of cool. I just have a feeling. Let's just go make sure where we need to be.
Yeah, Phantom Streak Nebula. Maybe that's what it is.
Maybe it is. But it's actually a planetary.
Well, it says it's a planetary, yeah.
Yeah. A planetary is a remnant of a dying star, dead star. And we're going to just do a long exposure just to see what we got here. We are going to go to some other objects too, guys. Don't worry. I'm just thinking it's kind of fun to do this, you know. But right now, we are at the Phantom Streak Nebula. I'm not sure if we're going to see the Phantom Streak Nebula. But I came here before and was somewhat disappointed. All right. Here we go.
There's a fair bit of dark nebulosity going on in there, actually.
I know. You can see it. So what I'm going to do?
Streaks and blobs.
Yeah. So we're going to... Actually, I think this is the Phantom Streak right here. I'm not sure. But the telescope puts things exactly in the middle. When it finds them, wherever the star goes that it tries to find, the star is like the jumping off point, like a star hopping thing. And then it goes exactly to the object and puts it right where the star was. Sorry, I had to turn on the unit here. Okay, now let's do a nice exposure here of this. And this one is going to be at 25 seconds. And we're going to turn off the blue, the hyper processing, so that we get a fairly normalized view. So let's go stack. Now when I come in, I may have to clear the previous stack. I do not. All right, good. So we should be okay. So if I come out of this now and maximize this, we should be able to have this all to ourselves. Let's see what happens. The blue, this green progress bar indicates the status of our exposure. Wow. Now that is really cool.
It is.
First of all, that's a satellite. And the satellite has ruined this exposure. It's probably a Starlink.
Thanks, Elon.
The Nemesis, but it's what we're going to use. I'm going to clear this because I don't want that in there. And let's just go back and watch the Phantom. Well, it's not the Phantom Streak. It's actually dark nebulae. So you see all these nebulae in here. This is all dark dust in our Milky Way. Again, remnants from supernovae past. When the Big Bang occurred, this dust wasn't made. Okay, only hydrogen and helium and a few other early elements like lithium were made, and beryllium. Okay, so this stuff really is made by stars that go supernova. Hey, Rockstar's here along with Amal. How are you? Okay. And so we're actually right in the middle of the Milky Way right now. And I'm actually going to change our indication of what this is to Milky Way dark nebulae, because that's where we are. Okay, and I'll just bring that up. So this is what we're actually looking at right now. Milky Way dark nebulae, dark dust in the galaxy. Okay, I heard somebody said it yesterday, dust bunnies of the Milky Way, and that's exactly what this is. Dust bunnies of the Milky Way.
Great big bunnies.
Yeah.
Dark.
No, considering it that like this right here, that little streak up there, that's probably it's definitely several light years long.
Oh yeah.
I mean, think about it. That's a lot of supernova, guys, to actually make this kind of stuff, you know? Hey, Prow, how are you? The Phantom Streak, Prow, it's a little planetary, and I can point it to you. It's this little green thing right here. That little green thing right there is the Phantom Streak.
See it?
See it?
Oh yeah, it's green.
Yeah. So the Phantom Streak, all right, is this little guy. Where did I say it was? It was a little green thing. It's this little green thing. Yeah, it's right there. It's that little green thing. Right there. I'm straining my eyes. It's there somewhere. Okay. Keep in mind that this is a 2-degree field all the way across, you know, so it's actually 2 degrees from here all the way to here, and 1.5 degrees from here all the way down to here. So that's 4 full moons across by 3 full moons tall. That's a big field. So when we look for things like the Phantom Streak Nebula, well, we're not giving an indication of how big they are. So sometimes they're small, you know. But if you notice, as time goes on here, we have stacked 4 frames here, and we're doing 25-second shots. And as we stack these frames, you'll notice that the noise that you see, the modeling, the dust, the noise in the dust areas especially, is actually going away. It's actually being averaged out, and this image is actually looking better and better and better as time goes on. Yeah, Mel Brooks' giant cleaning lady vacuum. Yeah, that's right. Actually, that was the ship, wasn't it?
Yeah, the ship morphed.
Yeah.
That's when I got disgusted with that movie. He sold out. He always sells out the end of his movies. He sold out the end of
Blazing Saddles?
Blazing Saddles, too. Let's have a musical.
And they go blasting through the other sets. That kind of crossover, I kind of like the crossover stuff. They're doing other musicals, and if they were actually real movies that they were making that they blew in on, that would make it even funnier. Yeah. Linda Marie, that's a great question. These dust bunnies in the universe, these dark nebulae, are we're about 30,000 light years from the center of the galaxy, roughly, and these dust bunnies are probably 6,000 to 10,000 light years away, and they are cataloged dark nebulae, so we can actually find out exactly how far they are away. But what you're seeing, and this I've talked to you about this before, all of you, what we're seeing here is a amazing time machine. We're looking back in time. We're looking back in time here. Everything you see is seen at a different time in its history. Okay, this star could either be in the foreground or a very, very bright star far, far back. Okay, and yeah, see, SkyTour. Yeah, so that's the thing. So we don't really know. Really what the universe looks like now. We really don't. We only see it at a snapshot in time. And the length of a human life at 100 years is nothing compared to the billions of years that the universe has lived. You haven't seen the galaxies rotating. You haven't seen galaxies in collision and ripping each other apart and reforming a new type of galaxy when they come back together again. You can't see that. We don't see that. To us, the universe appears static. It appears unchanging. But as you can see from stuff we've done, it's not unchanging. When we look at comets, for instance, we have taken shots of comets over 45 minutes, and you literally watch the comets moving through the sky over 45 minutes. Comet Neowise, Neowise, stands for near Earth object. And that was a wide-angle infrared telescope. Okay, WISE, Neowise. So that's pretty cool, you know. Hey, Wayne Pinkham, how you doing? Thanks for coming. I'm glad you finally found it. Awesome. You know, it's very nice to see you here, too. Yep. All right. So that's how that works, you know. The time machine aspect of the universe is something that I've really never gotten used to. Okay? When you look at the sun, it's 8 minutes old. When you look at your friend across the room and the friend sitting right next to you, well, that friend is a fraction of a nanosecond older than the friend sitting next to you, the light coming from them. So it's really strange to think about that, but everything we perceive with our eyes and our instrumentation is a snapshot in the cosmic time clock. And that clock depends on the distance of the object, that time. So that's pretty cool, isn't it? Cypher says, kind of like you can't see people age in real time, but pictures over time reveal it. Yeah, exactly so. You know, you don't see your own kids grow up in front of you, yet when you are away from them for a week, you notice something's changed. You know?
Oh, yeah.
So it's kind of weird, you know? Yeah, I'm getting some ignored frames, but that's okay. I think it's related to the fact that there's so many stars that sometimes, I mean, it ignored 13 frames and stacked only 6. So we'll stop it here. It could be the length of the exposure or whatever. Hey, Dr. Fox 2000, if you guys really want to see a very cool stream about volcanoes, okay, Dr. Fox 2000 is a man after my own heart. This guy has a fantastic YouTube channel called Dr. Fox 2000. He is covering the Las Palmas volcanic eruption of Cumbre Vieja, and he's got a lot of great information. So, Dr. Fox, it's so good to see you here. Thank you for coming and hanging with us for a little while. You know, I was watching your stream earlier, and some of the stuff you have done. He's got a record, too, of all of it. Very, very nice stuff. And he makes excellent commentary about the volcano. You know, and as an astronomer, I listen to it, and I'm never critical of people because, you know, everybody has different levels of learning, and this guy has it down. This guy knows what he's talking about, and I really enjoy listening to him and his commentary. So if you haven't gone to subscribe to Dr. Fox 2000, please do it now. This guy is amazing. But then don't forget to come back here. So thank you, Dr. Fox 2000.
I saw that one. I assume it's that same particular event that's really been going off the last few days.
Yeah.
Saw it a little earlier tonight, and looks like it's built up a huge cone around itself now.
Yeah, that's a cinder cone, and the kind of lava that's coming out is really interesting. It started as what's called an effusive eruption, where a lot of fairly runny lava was coming out, and it changed, you know, a little bit as it kept going on. What I think is the cool thing is there's like 8 vents now there, and Dr. Fox is here. He can tell us because he's on top of it. There's something like 8 vents that are have been active, and there is one that is actually doing quite a bit of stuff. And somebody actually said something like, "Ooh, is that coming out like supersonic speed?" No, there's nothing that's coming out faster than the speed of sound. But that doesn't mean you can't get a shock wave, okay? Because you can get a shock wave, and it doesn't mean that it's going to be at the speed of sound. It does not have to be the speed of sound. Yeah, see, it has 8 vents, yep. And what's interesting is they're kind of in a line with each other, and people are thinking, oh no, the whole island's going to crack, and we're going to get this mega tsunami. You know what? It's really not true. It's not really true. The mega tsunami was a theory put forth by Simon Day. I haven't talked to Simon, but I know one of the other scientists that knows Simon, and I've talked to her extensively in years past about his theory. And really, he said it, but here's the thing. La Palma is going to have to go through so much more erosion geologically before that event could possibly even happen. So they're not even calling for a remote prospect of a mega tsunami with this eruption. This eruption is really not that big, to be honest. Yes, it's smashed over and destroyed and overtaken over 2,500 houses, okay, and homes and businesses, but it's only gone a few kilometers to the ocean. It hasn't gone 20, 30 miles. You know, it's a fairly wide swath of lava. It's changed directions a few times and gone to different locations. But let me tell you, it's really, really a small eruption overall. It's just dramatic. You know, you see it. I mean, it sends stuff up into the sky, you know, 1,500 feet, you know. And when you see lava fountains, those are characteristics of things like those are characteristics, for instance, of things like a cinder cone eruption. They tend to do this. That's how cinder cones are made. and they throw out a lot of stuff. That stuff on the side of the cinder cone is actually more like glass. It's almost a volcanic glass. You don't want to walk in it with old shoes because it's going to just be it's only going to rip your shoes to pieces. I walked on the cinder cone a couple years ago out in Arizona, and I walked through lava fields, and that stuff is sharp. And the shoes I'm wearing now are the ones I was wearing there, and boy, was that stupid, because these shoes are now cut, and the soles are about to fall off because the cinders are so sharp. You pick up a wad of them, if you rub them in your hand, you'll have bloody hands. Okay, they're really sharp. It's like picking up pieces of glass. Now, the weathering takes care of it a little bit, but, not a whole lot. So, all right, we're going to see here. This, for some reason, this stopped doing. I think maybe what happened was it's possible that the telescope has moved enough out of the way. So let's go back here. All right, so here we are, and what we're going to do is we're going to go to a different location in the Milky Way. These are the dark objects that are there now. We only stacked 6 of them before we had a bunch of failures. I'm not sure why that failed. Again, it could be due to the fact that there's so many stars it actually confused the stacking program. That's kind of funny, isn't it? So that's really neat. Yes, XPFTP speaks correctly. This is a star over here, and this is a halo that is due to an artifact. With bright stars and a fast system like this, you can't really get rid of the halos. And Dr. Fox says, yes, that tephra is basically glass. And tephra basically is the stuff that goes up and cools and it falls down. It's the lava before it cools, or after it cools. And it becomes the basis of soil years later as it evolves and erodes. But let me tell you, it's really cool stuff. If you ever get a chance to go to Arizona, go to Sunset Volcano. Okay, it's north of Flagstaff, and Sunset Volcano is just a marvelous place to go. And when you see Sunset Volcano itself, you go, "Wow, look at that!" And they actually take that ash and they grind it up, and they create the material that you see on what are called cinder tracks, like tracks that are at like schools around it, where people run on the track. Now they're the synthetic material, but this cinder tracks is what they used to drop on. This gravelly type stuff, and that was ground up volcanic ash that you've been running on all your life and not even known it. All right. So this is cool, Daryl. Let's move on. And Ufi's here. Yufi Otori, how are you? So nice to see you. It's a big dog. How are you? And Isabella, our wonderful post-processor from Sofia, Bulgaria, is with us tonight. Hi, how are you? Yeah. And Yufi, I'm sorry if I pronounce your name wrong. You can tell me how to say it right. You can call me Cram. It's my name backwards if you want. Yeah. It's Oinatnad Cram. That's my name backwards. So, okay. Where are we going now? Let's go see. Let's go check out our view here. Well, we're still pretty high up, so that's pretty good. Let's see, what do we got down here? Some more to look at down here. Okay. We were just by the Phantom Streak, which wasn't really much of a streak at all. We can go up, though, huh? I think we can go up, right, Daryl? Why not?
Sure.
What's this guy? NGC 6807. Another magnitude 12 planetary. Yeah, the XPFTP, sometimes there are stacking errors, and I don't know why it happens. It does happen, though, from time to time. Can't explain it. But it is what it is. Let's do this. I want to go.
Blob there above.
This one or that one?
Either. I was thinking the one above, but
that one.
Either one.
Well, why don't we let's go here first. Let's go to this planetary first. All right. So I'm going to tell it to go there now and then come out. And while it's on its way there, I will come over here and set us to our proper values. Okay. And then 1 second. And then we'll do this. And now we'll notice that we're going to have stars. I got to get rid of stack though, because this has to be cleared or else it's going to just be overlaid by whatever else is coming. There we go. So this is the star that we're going to be aligning on right here. And so, yeah, I know we're not stacking now, so that's fine. Okay. XPFTP, yeah. If I have any problems, I'll call Evo. He's been very, very responsive to our issues with APT, which is, for those watching this program over here, that's over on the left side. That's the one we control the telescope with, and so it actually works pretty well. And he's very responsive to us. He's the author. Okay, so here's where we are. And what I want to do is I want to do one more thing. I want to actually check our location. So I'm going to give us a 3-second photo. All right, and then I'm going to solve for where we're located. Make sure that I can get our coordinates right.
Mark, would you excuse me a moment, please?
Absolutely. See you when you get back. I said this yesterday. Let's all leave now, and then when Daryl comes back, the room's empty. What I'm doing now is the telescope is comparing these stars, and it's trying to locate the star field for us automatically. Sometimes it takes 10 seconds, sometimes it takes 10 minutes, but I'm not going to wait here that long. If I can quickly get it, then I'll get it. And if I can't get it quickly, then I won't do it. We're very close to looking at what we want to see anyway, and I can always look for an object and then center it up and check the coordinates out. But our coordinates are almost good, so we'll just wait a few seconds. And these are big enough stars, it should have no problem finding us. It's just it has millions of stars to go through. And if we see a green bar across the top here, it means that we are successful. All right. So how is everybody doing out there? Hope you're all doing good, doing well. I am very, very happy with the fact that our telescope is back up and running. Not sure what that glitch was earlier. It's probably a glitch of the control program. Or it could have been a lapse of internet between here and 2,500 miles from here. But when we have Starlink, we're on the list. When we get Starlink, that's going to be a non-problem. We won't have a problem with it anymore. All right. The other thing I found is when I try to solve for the position, if I'm in the Milky Way, it actually gets very confused. It's actually better with fewer stars, which is kind of interesting. But we're good enough. I mean, we are good enough, so I'm going to cancel this anyway. I mean, I know where we are. Okay. Now what I'll do is I'm going to take us to Altair. All right, just to do my confirmation. So if I say Altair and go, it's going to go right to that star, and the star will be centered in the view. All right, and there we go. Keep in mind they look like streaks because over here in the camera controls, you'll notice I have a 3-second exposure that I'm doing. I'm going to do a 1-second exposure, and then there'll be shorter streaks, but you'll still see streaks. Okay, so there's Altair right there being centered up. All right. Hello. Oh, great, Wayne. I'm glad everything's cool. All right, so we've got Altair, Daryl. I'm just doing this for coordinates, just to make sure our coordinates are good. And because our coordinates within Stellarium here show us a little bit off of Altair, and I just want to kind of make sure that that's not a problem. It isn't a problem, but basically,
Altair is the eye of the eagle.
That's correct. And if we look at the mythology for this location, all right, and I zoom out, you can actually see that Altair is shown as the neck of the eagle, but again, the people that made up this mythology are basically taking free reign. It's not really what it classically has been. It's been the eye of the eagle, so that you have to slide it all down a little bit.
Yeah. Eagle faces the other way, too.
Mm-hmm.
The star to the lower left of Altair is actually the tip of the eagle's beak.
Mm-hmm. All right. So now, let's see here. Let's zoom in again. As you can see, we're really pretty close. Okay? But what I'm going to say is, okay, you see Altair's right there. It's pretty well centered. It's just below center. But what I'll do is leave it there. All right? And then come back here and tell the program here that Altair is our object we want to be linked to, and the object that we selected. So there's Altair. Altair has been selected, and now I'm going to say you're going to synchronize with Altair. This is where you will have your coordinates. So now we've told the program Altair is what you're looking at. Don't go off on me again, so it won't know. All right, so there we go. And now, if we go someplace, we'll be assured that our telescope will be pointing where it belongs. You want to do some more stuff, like I think I want to look down here. Like, I wonder if this is a real thing right here, if they just put that in just to be artistic. See that?
Yes.
I wonder what that is. Well, we're going to check it out. I'm going to select that little star, and we're going to go with that little star. There we go. And as you can notice, as you will notice, we're going to head there. And what happens is the telescope, if it's not a bright enough star, the telescope's going to find a bright star and use that as a marker, a signpost. Is that Terra Z? No, it's going to use OCAB over there. And then it's going to come back over here.
Can you drag the stellarium just a little bit to the left without disturbing what the telescope is doing?
Yeah.
I was just curious about that star named Deneb. Deneb Al OCAB Borealis.
Yeah, we probably could benefit from the constellations. Okay. All right, so now that star is going to be right in the middle. And there it is. Okay. So, if you notice, right near this star that we're on, there is this strange shape here. And there's another star up here. Let's go back to our this thing here and say, okay, it's there. So it might be this star here. We might be in a slight angle. So what we're going to do is we're going to take a long shot of this and see what we got. Again, it's just fun to explore. There's so many things to see.
Deneb Al OCAB Borealis is Epsilon Achille.
Yep. Okay.
Deneb meeting tail, I have to assume that's the tail of the eagle.
Okay.
One of the stars in the tail. I was just curious why it was saying Deneb down there when, you know, the big Deneb was far up to the north of where we are.
Yeah. And Deneb is the tail of the swan.
Well, there are many Denebs in the sky, I've mentioned before.
Mm-hmm.
I mean, Deneb Kaitos is the tail of the whale, and Denebola is the tail of Leo the lion, and there are others. And I guess we just found another one tonight.
That's right. Well, let's see what we got. Ooh. This looks interesting. Oh, look, we got a satellite. Actually, we got a tumbler. That took 30 seconds, because that's how long this exposure was. That took 30 seconds to develop, so the next one's probably going to be here going for 30 seconds, the same length. Let's see.
I guess it's pretty high
There
up.
it is. Yeah, it's at a high altitude, that's correct. And because you're seeing the dashed lines, you know what it's doing, guys? It's actually doing this. It's tumbling, so it's going like this. You can see it now because it's bright, and then it's less bright. And it's bright, and it's less bright. So what that is it's probably a rocket body that launched something perhaps to geostationary orbit. This might be, this might be 8,000, 9,000 miles out, maybe less. But by the length of this, and the time it takes to go there, we know in 30 seconds it goes a certain length in the sky. I have a program I wrote that will actually allow us to figure out exactly how high the altitude is in that satellite. I don't have it up now because I didn't expect it. But there it is. That's cool. Well, here's what I'm going to do. We're going to go into our stack here for a minute. And let's, now that we've stacked like 4 of these, let's go in and do some processing to bring it out. And now you can see what we're actually looking at. And I think now you'll be pleased. How about that, huh?
It's cool.
It is very cool. Look at that. We're looking at a beautiful patch of dark nebula here. And of course a satellite, which, you know what? Doesn't hurt this particular exposure, because it points out that we have tumblers. So what I'll do is this. I will do this. I'm going to save this like we have it. All right. I will clear the stack after I save it. And it's only 6 stacked frames. And I'll save it exactly as we see it. Okay, so you have it if you want it. Now I'll clear it. But wait, I can't because this thing is still there. Yeah, we gotta wait another 2 exposures. It might be fading from view, though, because even though it's far out, it's gonna enter the shadow of the Earth eventually. And I'm pretty sure that it probably has. But look at that, Daryl. That is just stunning.
Yeah.
All right, so let's now clear the stack and do this all over again. But you know what I'm going to do? I'm going to change it up on us. I'm going to go and not do 25 seconds. I'm going to do 35 seconds. I'm going to add 10 seconds to that. All right, and...
Yeah, it looks like you still have a little bit of that down at the bottom left.
Yeah, that's why I did 35 seconds. So by the time I'm done doing this, we won't have a problem with this. So I'm going to come in here now and clear this one final time. And we'll start fresh. So this new 35-second exposure comes in. And you guys are going to have some fun watching this, I hope. Neato.
If you save this, remember it's what you want. I don't know what you want to call it, but it's in Aquila.
Yeah.
Dark Nebula Aquila, something like that.
Mm-hmm. All right, so we'll just put that up so people can see. All right, and we have 1 frame done. We should be able to do a little bit of a process to bring it down. There we go. So now we're good, and now we can sit and watch. Now you see how mottled it looks and how you actually see noise, and I can point that out by zooming in a little bit. Let's go to 40%, and you'll notice that there's noise, right? See how this color and modeled color? That's noise that we want to get rid of. But as this works, it's aligning and stacking frames on top of each other. Each frame gets aligned and stacked, and the more you do that, you create a signal to noise ratio that's very high. That means you've got lots and lots of signal, stars, dark nebula, and lots of noise. But the noise is averaged out because the noise is changing every exposure. So it just gets all muddled out by the time you finish, and the signal stays the same because the star doesn't move, the dark nebula doesn't move. So over time, you get this beautiful image that stays perfect. That gives you a perfect rendering. And that's what we're doing. We'll go back to auto.
A lot of red stars.
Yeah, a lot of red dwarf stars in there, yeah. And some of them might be in this cloud. This is a beautiful area. This is going to make a nice photo.
Or star trains, too.
Well, you can't do without star trains. You know, they're always there. You're right.
Yes.
Yeah, we found a nice spot here, man. I'm going to take the dark level here, and in the adjustment over there in the histogram, I'm going to actually change where the dark level is. So it's going to actually make the image a little bit darker. All right. And now that's going to help us see this dark nebula better. Wow. That's pretty. Now what we can also do is we could do our hyper processing here, or I could just pull this line over here. This is the data, and if I pull to get more of the data, you'll see that nebula gets brighter, see? If I go all the way over, it's going to be just blown out and look terrible. So I don't want to do that. Okay, so I'm going to come back. What that's good for, though, is it shows you what might be lying behind there for you to get after. All right, so this is beautiful. And all that noise is going to go away as we stack more. I know, isn't it beautiful, Tara? Well, that's a great dream. She says, you couldn't recognize the pattern, but then again, you're forgiven for that because the patterns are they're crazy patterns. Okay, that you don't know which pattern is going to be which. You don't know where you are. When I would get lost in the galaxy, I would, as much as I think I know. Yeah. All right, so we're going to keep doing this. I'll move it over a little bit. I hope you guys are enjoying yourself tonight. I am. All right, so let's do what I promised we would do. Let's actually maximize and just make it all dark nebula. All dark nebula all the time. There we go. Look at that. Isn't this amazing? This is over your head, and you don't even realize it. People don't know what's there and why it's there. Charles Smar, holy cow. It's so good to see you, brother. Where you been? This is, as you can see, is a dark nebula in Aquila the Eagle that we're poking at it. And it really is looking beautiful. Charles Smar makes the trek out to the Pine Bush conference every year. That's where I met him a couple years ago. Great guy. Charles, where do you live? Where do you drive from? I know that Ronald comes in and he picks you up along the way. Are you in like Ohio or something? I don't remember. XPFTP, Midnight in the Nebula. Yeah. That's right. Thank you, Pete. It really is pretty. So we've got 10 stacked right now. 10 35-second images stacked. I discovered that if I go to like 35 seconds, and I could go minutes, okay, but you don't want to sit here for minutes. If I do private streams for myself, just doing it myself, I'll actually go and I'll do many minutes exposure. But it's almost like it doesn't need it. Oh, thanks, Prowl. Hey, this is actually science fiction, but science fact, right? So it's kind of cool. Let me see if I can work on the colors a little bit. It might change things up, and I'll have to modify it again, but it doesn't hurt anything. It's not hurting the actual data. All right. Okay.
That looks nice right there.
It does. It does. I just wanted to do a color balance. That's pretty good. Just think that black cloud of dust could eventually form stars, and the stars that it forms could eventually form planets. The dust is physical stuff, and the hi Martin Knobloch is here. I'll answer you in a second, Martin. This dust is not just dust. There's also gas in there too, and when the gas begins to self-gravitate and condense, then that becomes a blob, and that blob begets more stuff gravitating to it. And so in space, where there's no gravity except for that one little thing that's now gravitationally condensing, you're going to get something really, really big forming there. And it could be a star. If there's plenty of hydrogen gas, you're going to get a star. And then that star, if it's a star like the sun, or even a little bit more massive, or a little bit less massive, or a lot of bit less massive, then that could also allow planets to form. And those planets could then someday be hospitable for life. And that's kind of what we see here. It's amazing. You know, really amazing stuff. What's that? Dust, not gas? What'd you say there? Dust, not gas? Were you responding to something?
Oh, Prowl said, did you say the dark streaks is gas blocking light?
Oh, right. Okay. Yeah, actually, we've talked about it, Prowl. You know, this is dark dust that's hiding the stars behind it. It's not a void in the stars. It's not like a gap in between. And the reason we know that is because we can actually see the material here and get a spectrum of the material. Not us with our telescope, but I actually have the system back here to do the spectral analysis, but that's just boring for, you know, folks to come watch. But we'll do something like that with the telescope that's behind me right now, just to give you an idea, just so you can see. If you look behind me right now, all right, that telescope back there, that's the SkyTour LiveStream East telescope. Okay, the SkyTour LiveStream West telescope is a different telescope, and the Eastern telescope, okay, is a telescope that we're gonna have online at the same time as the Western. And the idea is that we'd like to take, for instance, a picture of the moon with the Eastern and the Western telescopes, and make for the first time in human history a 3D image of the entire moon. You know, you'd have to literally cross the country with your camera and take pictures and then make a 3D picture. I don't know why no one's done it yet. Probably because I'm saying it now. Someone's going to go and do it. I'm going to beat him to it. Fine. I don't care. I don't mind. Have fun. More power to you. Okay, we've stacked 17 frames here, and you'll notice now that noise we saw earlier, that modeling and that color noise that we saw here, it's gone. Look at how subtle and more soft these things look. Isn't that crazy? Yeah, electrical force. Charles Smar says, I once mentioned electrical forces in space are significant in space. Are they significant in nebula formation? What's significant is that sometimes, Charles, frictional forces between dust particles can cause electrical charges. Okay, kind of like when you rub your feet in the carpet. Okay, now you don't need air to have electricity. All right, so electrical charges can build up and hold things together. Okay, there's very little air on Mars. There's no air on the moon. Yet what you can do is I'll tell you what Charles is doing with the caps here in a minute. What you can do is actually go to the moon and clump the dirt together, and the static properties will actually hold it together. You know, I actually had to make lunar soil for a television show I did, and it wasn't the real thing, of course, because it didn't have the glass consistency that the real lunar soil does. But that's actually the kind of stuff that that soil has as a property. So I had to make that too. So static charges can be there in the absence of air. Now, why Charles put that in caps is because we, many times in the past, have said if you have a question, put it in all caps in the chat. So that's why he put that in caps so that I'd see it. And, of course, I did. So I'm watching the chat a little more carefully. So it's possible, and this was an agreement we had for years, actually. So it's possible I'll see the question anyway. But if you just put my name in all caps, all right, or Daryl's name in all caps, if you want to ask him a question, and then ask your question normally, then that's fine too. The caps catch the attention. Daryl, look at that. Look at how subtle that is. That is just beautiful. You know.
Yeah, as far as electromagnetic forces go, there has been some stuff in the press recently. One you may have seen, there's supposedly some sort of magnetic tunnel outside our solar system that they've detected recently. I don't remember much of the details of it. And it might have been that Sabine Hassenfelder lady on YouTube.
Yeah.
She talked about the reach of electromagnetic forces.
Yeah.
The universe recently also.
Yeah, that tunnel of it's not like there's this gigantic magnetic tunnel in a perfect circle around Earth. That's not what it is. It's the whole region of space we're in our galaxy has this electromagnetic, they're calling it a tunnel, but electromagnetic, charges, okay, that are actually forming a somewhat linear curlicue feature. I don't know. I haven't seen the details. But that's actually, it's an interesting find, but it doesn't change everything about what we believe. It's something that could have been predicted, actually, but I'm not sure. We're at 24 stacked frames right now, so this is beautiful. I would say that we're pretty close to being done with this. Yeah, Donald, I understand. You know, you said you've been in chats with people putting caps. You're right. That's why I say just put the first name in, and it'll be fine. Charles was responding to exactly what he was told to do, not just by me, but by many other hosts who said, put your questions in caps. Primarily for the radio show, when we had actually live chats too, people would ask questions in the chat, and they would put them in caps so we'd see them. But, you know, thank you for pointing that out, Donald. So it's not a worry. We are all okay. Yeah.
Don't make me angry. You wouldn't like me when I'm angry.
Okay, Hulk. Are you Lou Ferrigno? I shouldn't do that. Lou Ferrigno is deaf.
He is?
Yes.
I didn't know that.
Yeah. He's deaf. That's why he talks the way he does. Made great strides in his career in bodybuilding, but he was deaf.
Huh.
Yeah. Weird guy's here. Where is he? I didn't see him. Must be up above. Daryl Angry Bear. Oh, Martin, thank you so much for. I am so sorry, Martin. You asked me that question. Um, and yes, you can hear it online, Donald. Martin, to answer your question, is the filter we're using. I only have one filter in there right now. On this telescope, I have a filter wheel with 5 2-inch filters I can rotate through, including a spectral filter too. But this telescope out west, because of the nature of the telescope, I actually took the secondary mirror off. It's a Schmidt-Cassegrain, so the light goes down in a typical Schmidt-Cassegrain. The light goes down, and this is for others. You may know this already, Martin, so I'm sorry. The light goes down, hits the primary mirror, then comes up to a second mirror in the middle of the opening, and then goes down through a hole in the back of the rear mirror and out to the camera and the eyepiece, etc., whatever you're going to use. However, in this case, we have the same setup, except that we've taken out that secondary mirror, that second mirror. That if the telescope is this big, the secondary mirror is like this size. The light goes down, hits the main mirror, comes up, and instead of hitting a mirror, it goes through a special lens system sticking off the front of the telescope that drops the focal ratio, that is the speed of the telescope, to f2 from f8, making it 25 times faster and making the field much wider. And then out of that, it goes to a filter, and out of that, it goes to a camera. Okay, so when we look at our photos of stars that are overexposed, you actually see the cables sticking out from the camera. All right, these are very pleasant stellar images right here that we're seeing up here. Those are pleasant, but you can see a faint ring around this one and a little bit brighter ring around this one. Okay, that's really something. I'm really liking this. All right.
Yeah, that's serendipity in action.
You got it. We didn't know it was there, and we found it. All right, we are going to stop at 30 frames here. We're going to pause it, and you betcha I'm going to save it. Look, this detail's all going to come out really, really pretty. So I'm going to save this as we're seeing it.
So many red stars.
I know. Well, there's more of them than any other kind in the universe.
Yeah.
All right, so I'm saving the FITS file. It's already saved. And now I'm going to save the image exactly as we see it here in case you want to just get pretty pictures. And for those who don't know, we have a live server that's connected to our observatory, and every time a picture is taken, once it's finished taking a picture, like the ones I just saved, they're already on their way up to the server, leaving the observatory, heading to the cloud, and they will be available in the next few minutes to anyone who has that link. And it's a free link to all of you. You can find it in my Facebook page as a pinned post at the top of my Facebook site, Mark D'Antonio. And you can find it underneath the SkyTour LiveStream Facebook group. And it's pinned there too, so you can see it. So you just click on it, off you go, check it all out, and you can see these amazing objects for yourself. You know? So that's cool. And so if you're interested in that, let me know. And we can arrange to get the link up here in just a minute. I'm just going to go get that link for you if I can. It's going to have to wait because I'm actually trying to do something here. Yeah, Rasa, yeah, that's a really good telescope. All right, so we saved them. Now we're going to clear them. I hate to say goodbye to this, but it's still here. We saved it. Or did I? Yeah, I did. All right, and now we'll come down here and change this back to 1 second. That was a nice serendipitous find. I really enjoyed that.
Mm-hmm.
And now, see, even if we do our amazing hyper process here, it doesn't show us the dark nebula, you know? I gotta get rid of the stack now. I thought I killed it. I did not.
Thank you, Isabella.
Oh, Isabella, thank you so much. Very nice. Thank you. Okay, so now we're going to have our camera here with our finder mode, or our high processing mode. You can see the little remnants of those there. Very cool. I know he actually said he had to leave. I apologize for saying that. But that link that Isabella Melamed put in for you is the link to our OneDrive. It's the link to the Observatory server where you can get any of the photos we've taken over the last several months. You just click down the directories and go into them and get what you want and have a ball. So where are we going to go now? Let's see. We're here. We're going to head north along the rift. You know what we're doing? We're tripping the rift. You know that.
Uh-huh.
We're tripping the rift. All right. And now we're going to put up our equatorial coordinates. Now that's the world coordinates that are just put out over there. And this guy we've seen before. Okay. And we've seen the Dumbbell Nebula before. But planetaries aren't very impressive, except the Dumbbell is. But what I would like to do is check out this guy right here. We're going to go check him out. That's pretty cool. NGC 6823. We've been looking at dark nebula. It's time we look at something that's not a dark nebula. And it's an emission nebula. Yep. And let's see the star it's using as our hopping off point here. Okay, so this is where this puts the star, right? Well, when the object is found, it's going to go right here, right where I am. Okay, right where my cursor is, that's where this object is going to be. So I'm going to keep my cursor there, and you'll watch the object going to show up right under there. What a surprise! There it is. See? So that's how accurate the telescope is. Marianne is here. You know what that means? It means she's in Las Vegas. When did you land, Marianne? 5 o'clock? So you're probably at the hotel now. And how'd you get from the airport to the hotel? Did you have to do a Uber? I don't know if she can hear me. All right. Here's the nebula. Let's go check it out. This is kind of cool. Those of you who know Marianne know that she's instrumental to SkyTour LiveStream. She is the business manager for our group. She knows exactly what she's doing, and she has great ideas. It was her idea for us to do things like this. To put up the name of the things that we're looking at. Simple as that may be, you know what? I don't think of it. And Daryl said, "Oh, I'll watch where we're going and I'll put it up." Well, neither of us remember, you know.
What?
Exactly. Put up the name of the object. Remember, you said you were going to put up the name of the object, and then neither of us remembered to do it. So. Yeah,
it didn't last very long.
Yeah. Well, now we got it. We have it all set. We're doing it. Okay, so we got a 30-second shot, or 35. What did I do? And this is going to be this little nebula that's out here. 35 seconds. Okay, and look at that. Wow. That is pretty cool. See, these are things like, here's the thing, that these areas of the sky, these areas of the Milky Way, you know, they have very hot stars. And when these hot stars are in the process of spewing out their energy, some of that energy is in the ultraviolet, and the ultraviolet energy is going to ionize, that is, make the electrons in the hydrogen gas leave the atom. And now you just have a proton down there for a minute. And then the electrons leave the atom. That's called ionization. And then they will spontaneously fall back into the atom. And as they do, or into the nucleus, and as they do, they become an atom again, especially with hydrogen. And to do that, they give off a characteristic red light, which is what we see here. Right? So this is what we call hydrogen alpha, right? Or H, Roman numeral 2, H2. And that's cool. So this is a neat object we're looking at. So it's actually fairly extended, but look at the stars. Look at
Also
the
known
sheer
as
number of stars.
photoluminescence.
You're talking about when you ionize?
Yeah, well, the release of the hydrogen alpha light. Yeah.
Yeah. The only difference is photoluminescence doesn't have to happen at high temperature. This does. Okay. This is a high temperature process, which is something that that really depends on the energy of the light. So if it's going to be ultraviolet at this high energy level, it's going to also have a lot of heat associated with it. If there's dust particles, they're going to heat right up, and the atoms are excited, and the ultraviolet energy tends to heat these atoms up, and it will also tend to ionize and knock those electrons off.
Got interesting bands of dark nebulosity here too.
I know. Look at, we got one right here. We got some right there.
It's like a river there on the right.
Yeah. That's pretty cool. It might be a river. Might be a river. We're just gonna let this go for a while. See what we get.
What object was this?
It's on the screen. Oh, you can't see it because you're looking at. Okay, sorry. Fair enough. NGC 6823 in a Mission Nebula.
Okay. We're still in Aquila?
I think we're in Cygnus now.
Yes, sorry.
We might be in Cygnus or Sagitta. Let me go check. We might be in the border.
Sagitta was the last thing I remember seeing.
Okay, let's just see. There's
yeah,
Sagitta.
You're right off the tip of the arrow right there.
Yeah. No, actually, this is where I am.
Oh, okay.
So let's put up the boundaries and see where we are. Okay, so we are actually in Cygnus at this point, I think.
Yeah. Well, that's Alberio there to the lower right, isn't it?
Yeah.
No, it's not. There's Alberio.
That's it. But
yeah, okay. Still in the neighborhood.
Well, where are we? Oh, we're in Vulpecula here.
Okay.
That's interesting. Yeah, this is Vulpecula. So Alberio is just over the border into Cygnus. These red boundary lines are the boundary lines for the constellations. So if I back out here while we're taking our image, you can actually see the boundaries of the constellations. Really cool riding up through the nebulae tonight.
Mm. Yeah, that's Sagitta to the arrow, just to the left.
That's right. Let me pull it back out.
Vulpecula, the little fox, just to the right.
Yep. Yeah, and if we actually show that, I gotta zoom out a little bit. There's the arrow, and there is the fox, Vulpecula, right off the eagle, Aquila, and right below Cygnus the Swan. The eye of Cygnus the Swan is this beautiful double star, Alberio. A true double star. You know, it definitely has, there are two components. All right. There we go. There's a lot of these little tiny areas in here that are just beautiful. Little nebulae that just like stand out. You know, that no one ever goes to. I mean, they're lonely. They just want to be seen too. You know?
Cool pick.
Yeah, look at that. You know what, guys? When the winter sky comes up, yes, the Orion Nebula is going to just knock your socks off, of course, because it's going to take up a great deal of the screen here. But the other thing that is going to happen is we're going to be seeing the Rosette Nebula, and the Rosette Nebula fits inside the frame of our camera. So it's going to be really, really pretty. You know, make sure you hit the thumbs up and subscribe. Let us know you care about us and let us know you like us. You know, because we can't wait to do this again for you. We just love what we're doing.
The rosette will look like a king-size, bigger and brighter version of the star cluster and the nebulosity here.
That's right. I was just to say that's what reminded me of it.
Huh.
The rosette is bigger and looks like this. All right.
But Marianne's jetting all over the place. She was in Seattle.
That's right.
Last weekend, wasn't she?
Yeah.
Or sometime recently. It was chowing down on seafood. I remember Dungeness crabs.
Yeah. Dungeness
Now
crab.
she's partying down in Vegas.
That's right. And you can't keep that person, you can't keep that girl down, you know? She's off doing her thing. All right. I actually like this song. This is a cool song. I don't know why I like it so much. I'm liking this. Look at that right there. Look at this. There's a streak right here.
Mm-hmm.
See that? You know, we've got this guy right here. Look at that. Just coming down like that. Just going down like that. That's really neat. You know? Wow.
Looks like your focus is holding up pretty well tonight so far, too.
So far. So far. Yeah. So we've done 15 of these at 35 seconds. The other thing too, it is cinematic, Isabella. It does seem that way. That's right, Vera Lucia. Flying carpets and 1001. Yeah, you're right. Prowl says, how many stars are in that picture? You know, that is just... I'd have to say there's probably maybe 2,000 stars in this picture, maybe more. I mean, actual stars that we can see, if we were to count them, I think we'd get up to 2,000 in no time. But then these are all star clouds over here that are hidden behind here. And we don't know what those are, you know. So... And no, this is not Lawrence of Arabia, Donald. That score we just heard, I'll just go back to it for a moment so I can give you the name. It is... Yo, where is it? This is it, but let me find out where it is. It's called Desert Caravan. And we'll go back to the other one. I'll go ahead to another one too. Okay, we'll skip that. Now we'll go to another one. Oh, Donald, we are definitely in the Milky Way. We are actually aiming away from the Sagittarius arm of the Milky Way, and now we're looking more toward the Cygnus arm of the Milky Way in that direction. And we'll be looking toward the Perseus arm in a little while. Our vantage point is from within the galaxy, so it's like being inside a forest, looking through all the trees to see what's going on, you know. Okay, I gotcha. I will play it again. I do really like it. By the way, hi DK. Greggy, 2,362 stars. Very well said. Yes, of course. I think you're absolutely right. Give him a cookie. Yeah, you were close. You were very close. I'll bring the volume up for you.
Should play this for the elephant's trunk in the caravan.
That's exactly right. Or when you're riding the elephant. That's all right, DK.
I'm going to step away for just a second. Excuse me, please.
Sure thing. DK, you're no creeper. Look at that. Yeah, I did have my playlist in the corner of the screen. You're right. All right. Yeah, I actually like the music that actually sounds like it's those from like Arabian movies you've seen and things. I actually really like that. It's those minor tones. You know, and I really appreciate that. I'm a percussionist, you know, I played drums for many, many years. And I play also, oddly, the didgeridoo, which people from Australia know that the indigenous people there, Aboriginals, were the creators of. It's basically a termite hollowed out log that you can actually cause a standing wave to occur, and when you go inside and you get this really loud bellowing sound, and over the years I figured out ways to make that sound really resonate, and I'll tell you one thing, it actually calls animals amazingly. I mean, I was sitting on the front porch here playing the didgeridoo one night, just to, you know, it's like a meditative thing. It vibrates your whole head. It makes you feel kind of good. And when I turned on the lights, I had 2 raccoons sitting on the front porch with me just listening. I don't know why they did it or what they thought was going on, but they were there, you know. I call them Eric and Frank. You know, hey, Eric and Frank, they're here to listen to the music. And then I made something called a bull roarer, which is a paddle that's a little bit warped and spinning on thread. And when you spin, not thread, but rope, and when you spin it, it starts to make this really cool sound. It goes, and then when it winds up, okay, then it starts to unwind. So it's winding up as it goes, and you keep spinning it, and then it unwinds while you keep spinning it. So it goes, and it just goes on and on and on. And those were used as signaling devices because that sound would travel for miles. So, and the Aboriginals in Australia were the indigenous people, like here we call them Native Americans. My mother was indigenous. She was Native American and Irish. Okay, and so it's not the same at all as Aboriginal indigenous, but it's very much the same culture and appreciation of the earth when it comes to that. So that's, I think, where I got my appeal to, and my appeal of the universe. I just love the universe. So it's really cool, and I just love what we do, you know. So we've done... Go ahead.
We made bull roarers when we were kids.
Yeah, weren't they fun?
Yeah.
They could hurt you, too, if you got hit by one that's in full spin.
Yeah.
Yeah.
That was a long time before Crocodile Dundee. That's
right. I made them as a kid, too. We made them with, like, strings between our fingers and just pull and... You know? Really cool. And the vibration would really, like, makes your hands go nuts after a while. But it's really cool.
Yeah.
All right, we're done with this object here. I thought that was pretty cool, though.
It is.
So what'd you say there,
I
Daryl?
I think we made them out of, paint stirring sticks from the hardware store.
Oh, yeah. That's right. You're absolutely right. I used a paint stirrer. My father got mad at me because I would take all his paint stirring sticks and like cut them up and make bull roars out of them. You know, you put thread between them and you pull them. You know, and they'd really go fast. And then if you get them going too fast, because when that stuff it has a life of its own and it goes and it's like it's mesmerizing. And if you pull too hard, the string breaks. And the whole thing falls apart, and you're like, whoa. And it's like a total upset to your head. I know that's weird. You had to be there. Okay, that's been saved. So now we're going to come out and go to 1 second. We did like 27 frames, I believe, on that. That's cool. And here we are. Now let's get some data. Do 1 second shots here. Gonna get rid of the stack now because we'll need it. And boom. There we go.
Red stars really showed up in that hybrid view.
Yeah, I'm not sure. I'm not sure how much of that was another satellite. Told you. Zoom. That's a north-south bird, by the way. That's one going north and south.
Polar orbit.
Yep. Yeah. Sometimes the spy birds are in a polar orbit.
Yeah.
All right. Let's get our high processing finder going. And let's first, okay, before I do this, I actually want to get us back so we can watch the telescope. I don't want to do any movement without being able to see this telescope visually. If something goes wrong, I have a way of killing everything, so we can start over if we have to. All right, so we're going to move up north a little bit, and
You ever look at M56 Globular?
that's nearby.
That was just to the lower right of Alberio.
I thought it was, yeah. Well, let's go look at it. It's going to go to Alberio as a star that it wants to. I mean, I could just go over there, but I'll just do it with the telescope. I have it go. You can watch it go. And actually, you'll see Alberio. So when we get to Alberio, because I have a feeling it's going to use that, I'm going to get out of this mode so you can actually see the colors. See the colors? The orange and blue? Right? Look at that. And when you stretch out a star like that, that actually shows you a little more of what you can see. You see the colors better that way. All right, so orange and blue. It's overrunning the blue right there. So when it goes, it might do that again to go down to M56 right over here. But as it does, watch the star colors, orange and blue. It's a K star and a B8, which is a star, a B star that's actually in the later. It's almost a F star. So A star. It's almost like like it goes O B A F G K M. You know. So that's cool. All right. So there should be a globular in here, right? And we don't see it. Well, that's because if we give ourselves some processing, we see it right in the center. There it is. So we can try just doing a single 20-second shot, because the globulars typically are so bright that 20 milliseconds. No, they're typically so bright that you don't need a lot of time on them.
Yeah, I'm sorry. That's another one probably you need a lot of focal length for.
Yeah, that's okay. Don't worry, Omega Centauri will be our target eventually. Yeah, we can get rid of this right now.
Hey, it's a Messier object.
Yeah, that's right. It is this Messier object.
No M13, but still.
No, but you can actually see it's pretty cool. We can actually zoom in a little bit on it. go to say 40% maybe. Okay. So not as impressive as you want it to be, but then again, we do have an issue where our stellar focus of the stars is a little bit problematic, and that's because I have to just get out there and fix the lens system, because the main lens of the telescope, the main mirror, and the lens on the end of the telescope that I told you about is crooked a little bit to the mirror, and that happened in a crash where the telescope whacked the lower part of the mount, and it happened from here. I didn't do it. The telescope went out of control. That happens sometimes. Thankfully, not a lot. It happened only once. We fixed it, and it hasn't done it since. So I'm guessing that as long as you follow the same process you've always done, it'll be fine. However, it knocked it out of what's called collimation. That is alignment. So we're going to have to figure out something. All right. So why don't we go back to 1 second here and look for something else that might be fun to examine. I just love zipping through the Milky Way and looking at new things. It's a great deal of fun, Brian. Did you see what I did there? So that's where we are. And you know what I wanted to do? I'm going to do it. This little tiny grouping here. You don't see... Hey, Raymond, how are you? Raymond, I sent you a package today as a thank you for your generous support of SkyTour LiveStream. Ah, Martin, that's a great project. Martin Knobloch says, my project this year is to photograph all the Messier globulars from Philadelphia city skies with a 10-inch SCT. That means Schmidt-Cassegrain telescope. Still missing a few. Well, that is really cool. I'd love to see that when you get there. And Tara's correct. It was Family Guy. Yes, it was. All right, so we're going to go to this object right now. And it's a couple of tiny little stars with some nebulous detail around them. And I think that they're pretty cool. Actually, it's sort of an unnamed thing. I don't think it has a name. So it's a double star for sure, but I don't know why it doesn't... Oh, it went to solder. Look at that. This is solder. This is Gamma Cygni. It's the central star. It's where the wings of the swan connect together. And that's it's the third brightest star in Cygnus. So alpha, beta, gamma. And this is gamma. We use Greek letters to define early on the brightness of the stars in their order. Look at that little nebula. That is just so pretty. Wow, I like this. Daryl, you like star chains. What about these? Look at this.
Uh-huh.
All right, let's check out this amazing little beautiful well, gem hiding amongst all the others, shall we? Let's do we'll do 35 seconds on this guy. I don't think we'll do too many, but we want to just check him out. All right, so we're gonna pop out of our high process mode and go into our stack, clear anything in the stack that needs to go, which is this from a previous photo. And now we're underway. You can see the progress bar over here doing its thing. And this guy here is something that can move way the heck over here. I don't need it way over here. Hey there, weird guy. Okay, so now let's check out what we got. Wow. Oh. Look at that. Now that is cool. That is cool. Let's just look at that. Bring us that beauty. Can you believe that this is an unnamed object? At least it's unnamed in our planetarium. But look at all of that beautiful stuff. That is just gorgeous. Wow.
No name, or Stellarium just doesn't have a label?
Stellarium doesn't know what it is, but obviously there's a name for it. We just don't know what it is. Wow, look at that. Again, you'll notice the noise in between the stars and the blackness. Okay, that's going to go. That's going to go away, and this is going to look softer and a lot more pretty in just a short time. Thank you, Raymond. I'm glad that you enjoy it. Okay. All right, let's
That's really something.
isn't it pretty? It's developing. It's like developing an image over time, you know? It's just beautiful. You know? That's really pretty. I like this. What's funny is you don't see all the rest of the stuff that's out here, you know? But it's there because we're getting an awful lot of stars that can actually do this. They can actually ionize the hydrogen like that.
Donald says, so the bright spot is part of the dark clouds surrounding it? Question mark.
Actually, the bright spot is the extent of the ionization of the hydrogen in the area. It could stop at the edge where that black ends, or that black starts, but it also could stretch into it, but the star's energy can't ionize that far out. So there's a practical limit. If you had, say, a perfect space that's the same everywhere, and you had a bright hot star in the middle, and you had full of hydrogen gas, all evenly spaced, you'd get a perfectly spherical nebula of hydrogen alpha, this red that we're seeing, out to a certain distance, but not beyond a certain distance. That certain distance depends on the total energy output of the star, the ultraviolet output of the star in particular, and how it falls off as it gets farther away from the star. Okay, as it gets farther away from the star, it's actually going to get less intense. When it gets less intense, there'll be a certain point where the hydrogen gas can't be ionized any further. And so from Earth, what we would see is a perfectly spherical hydrogen bubble, effectively. And it'll look like it stops rather dramatically. But that's how that would work. And DK, ask miles across in a nebula. That's it. You want to talk about this stuff in light years, okay? Yeah, light years. Okay, and so this nebula right here, probably, I'm gonna guess, it's probably 4 to 8 light years across. Maybe depends how far away it is, because it could be a very, very large thing far away, or a small thing up close. See, but if it's around 1,500 light years away, then it's probably more like 6 to 10 light years across at most. That's my guess. Maybe less. So, but it's really something. You can actually see some really nice dark nebula in here, right there. And these things are now developing well. You notice that the noise that we saw, the modeling and color noise we saw in this dark, is now gone. All right. Incidentally, all these images are going to be literally 500% better once I get out there next week and fix the problem with the telescope. I said next week. Yeah, it is next week. I'm going out on next Friday or next Thursday, the 4th, I think. And then I'm going to be there till the 12th. And so next week, I teach astronomy in the desert. And then the following week, I go out into the desert again, like literally 100 miles the other way. And I will be processing and working on the scope and taking care of little nitpicky things to make sure that this is most important, that it's the telescope is properly aligned and collimated, it's called. Thank you, Raymond. Who'd you ask if they were lagging?
Marianne.
Oh, no, I think she's just not, paying attention. She just got to Vegas. She's probably talking to all kinds of people.
Oh.
So I imagine that's what's going on. You go to a conference like this, and it's like you're in the hotel room, and you're like, I got to go downstairs and see who else is here. It's fun. I get it. But she says she's going to Colorado next. That's what she said.
That's what she said.
Look out. Did she say not sure Denver, maybe come visit you?
That's what she said.
Ah. Well, you better watch it, because she'll hold to her promise if she does.
We'll see.
Yeah, you'll just have to meet her at a restaurant, so that she can't do anything like tase you or anything like that.
I would hope not.
She will.
Tase me?
Yeah. She would do that.
I was about to tease her earlier and ask her if she still packs her handcuffs, but I don't think I want to go
there. She doesn't. I know that for a fact, but she's packing wherever she goes, I can tell you that.
Yeah.
Yeah, very cool. DK says, okay, Mark, if you were Captain Picard, yes, what galaxy would you take your crew to investigate? Oh, that's an easy one, man. Let's see. Mr. Crusher, take us to the Whirlpool Galaxy. That's where we would go. I think it'd be pretty cool. And then after that, I'd say, Mr. Data, how far away is Measure 82? It is 4.3 million light years from our current location, sir. Well, engage, Mr. Data. Yes, sir. And we'd go check it out. It's not 4 million light years from us, just so you know. It depends where the Starship Enterprise was.
Even in Star Trek, that was an interstellar scale kind of thing, not intergalactic.
Yeah.
It's really pushing it.
Mm-hmm. But it's true that if you could actually push the boundaries, you would, wouldn't you? Yes, you would. I know you would. 17 stacked so far, friends, and I'm going to do a little processing here. I'm going to take and just try and lower the intensity just a little bit of our stars. Just a tad. A little more of a tad. Okay, let's see what we got. Yeah, that kind of lets us see more detail. One of the things I do, and I told this to Isabella, who is in our chat, of course, is I would take and remove all the stars from the images. And there's a way that I showed her how to do that. It's not the best. It modifies the data badly. You don't want to do that. But, you know, it is something that, you know, it is something that, you know, helps us to see things better.
Pictures like this, though, I mean, the star fields are half of what it's all about.
You know it is true. Isabella, you got to give it time. If it's not on the server yet, it will be there. Keep in mind that we're tying up bandwidth by doing what we're doing. We're doing time exposures. And so the computer has to time slice and take imagery and push it up the same pipe that it's getting to you, from bringing all this to you. And so it's going to be a little bit longer. Usually after I sign off for the evening, the computer will stay active until 6 a.m. And at that point, the computer shuts down and it starts up at 6 p.m. After it starts up for a maintenance phase at, you know, from 8 to 11 Arizona time in the morning. And if I have to get in, that's to me that's 11 to 2 my time. Perfect time to go and do some maintenance, and if I have to, and some cleanup of a hard drive or whatever, you know, stuff like that.
Can I make a suggestion?
Yes.
When you're done here, before you move on too far, maybe try recomposing this image. Just slide a little bit to the left.
Yeah, I was with you on that. I was thinking about
get
that. Get that star out.
Star out of the field. Yeah.
Yeah, I was already there thinking that, just to try it out. I think if we go here, I'll show you where we're looking. And you look at that bright star. Okay, if you look, there's that star. Okay, so if we close in here, let's just do this. Center it all up. Okay. So this is where we are. Okay. Now the telescope says it's there and not on that. So let me look at this and see. Yeah, see, it's a little bit off, I think, and I have to tell it to. I think I have to tell it to move a little bit. So I will do that. Very soft reflection nebula in there. It's really pretty. And now, I'm going to do this. And then this to try and make sure it's where we need it to be. Okay, so now the telescope is where it needs to be. I mean, not the telescope. The program thinks we're at this spot. And we have that star right there, which is this star right here. See how far it is?
Yes.
Yeah. So this thing, this red square is at the right orientation, the same orientation as the telescope would be. So it's looking where we're looking. That's one of the things I made sure we had. Because this could have been like all over the place in every which way, but it's not, because I don't want it to be. All right.
Yeah, you're still south of the. You're not past the zenith. I mean, the image hasn't flipped or anything.
Correct.
Yeah.
Okay, so let's stop here at 25 stacked frames, and we're going to do a move. Come on. Are we doing this again to me? Okay, we're in the process of losing our connection again, are we? Apparently so.
Uh-oh.
Well, it is what it is, right? There we go. So, it's back.
Be curious to see what your server was running at
Yeah.
under processes.
Mm-hmm. Yeah, it's actually definitely. Oh, okay. We're having an issue with the connection. So let me get out of this again. It's the access software. It's not doing what it's supposed to do sometimes. Wonder why that's happening. And it's probably going to say that. Yeah, it says it's down again. But we know that it won't stay down again. It won't stay down for a long time. All right. Let's hope. All right, claims it's back. I'm going to connect, see what we get. Almost 2 hours exactly from the first time? Is that true? Okay. It's the same thing too. It goes to connect when it's there and then it doesn't connect. Now it says it's back again. It's got to be intermittent internet issue. Yeah, that's what's got to be. And we're in 2 hours, 16 minutes. Now we're authenticating and we're back. All right. So we have 2 hours now until it happens again. All right. So what we're going to do, as you can see, this is all set. I'm done here. I've got 29 now. It kept going while we were off in Never Never Land. We'll save this. All right. It's now saved. And then I'm going to save it exactly as seen. God, I can't wait to fix these star images. Holy cow. You can't imagine. All right. Then we're going to get out of this and go back to our 1 second shot here. 1 second. And oh, I saw a faint satellite in there. A faint satellite trail. Okay. And now let's go back to our view that allows us to look at things. All right. And now you said you wanted us to move westward a little bit, or is that?
To the left.
Okay.
Is that west?
Yeah, I believe that you want us to go. Actually, you might want us to go east. Move that star out.
Yeah, just enough to get that star out of the field.
There it is.
Okay,
And
try that.
This you must should go down a little bit. Maybe center it up a little more.
You're the boat. You're the pilot. You're the captain.
Okay, Mr. Data. Let's see what's out there. All right. Here's what you guys what we're going to do. We're going to take this now, and we're going to do another. We'll do 25 seconds here. All right. And 25 seconds, remove our hyper process. Go into the live stack. Remove any imagery that were from the previous. Now we're going to actually have this over here. And the more what's in here will be more visible now. So here we go. All right. And the first one comes in now. And there it is. And we got to just do a little processing on it. And there we go. Oh, look at that. That's pretty.
It is.
We're going to let that cook a while, shall we?
Sure.
Look at that. Wow. Isabella, that could be why the files are uploading slow today. Donald, it's okay. I saw that you put it in all caps, and I'm not going to yell at you for it. That's just fine. You know, if you're asking a question, you just put my name or Daryl's name in all caps, and that way we know. Because when we glance at the chat, we won't miss it that way. Otherwise, we just see small letters, and we sometimes don't see them because we're doing other things. But thank you. Oh, so you want to hear Sean Connery? Wow, listen to me, Miss Moneypenny. That's Sean Connery, Vera. Whatever you say. What, you expect me to talk? No, Mr. Bond. I expect you to die. Remember that?
Oh, yeah. That's what inspired me to
build lasers?
want a laser.
There you go.
Oh my gosh. I wound up with 14 lasers.
Wow. Well, that was you were in that business for a while, right?
Yeah.
Wow, that's cool. This is really pretty. See, these clouds, these are called diffuse nebulae. And these diffuse nebulae are just absolutely beautiful. And they are the result of ionization by stars in the area. Not necessarily stellar nurseries like this guy right here. These, you can see, they're a little bit more intense. There's a lot going on in there. And maybe within the dark nebula that we can't see, we need to have an infrared telescope on this, like the James Webb Space Telescope. We'll find that there are stars in formation there, just like we see in the Orion Nebula.
There's interesting things going on in this picture. To the upper right of the bright nebulosity, there looks almost like several vertical rows of stars. A little bit higher up.
Yeah.
Nope, farther down.
Well, actually, there's a vertical row here.
Yeah.
It's like
get closer.
Okay.
There are like 3 or 4 rows right next to each other, vertical. If you go at about 1:30 or 2 o'clock from the red nebulosity, up a little higher, right there, just above that. See those? There's a blue row and a red row and a yellow row.
Right here. 1, 2, 3. Interesting.
And then the star fields up in the upper left. You've got some nice bright ones, but they're not so bright that they cause the halo effect.
Right.
And the one bright one that's highest up, I wonder if that's not a star, because that looks fuzzy. No, to the left.
This one?
Above that, to the upper left.
Oh,
of that. That right there.
Yeah, it looks like a star that's just a little bit brighter, actually. It does. To me.
Fuzzy to me.
All right, well, we'll be able to look. We will be able to see. And then over here is another focus that you can see right there. There's something going on right there. In here. There's this beautiful horizontal dark nebula right there, which is really cool. A necklace with a ruby on the far left. Is this the necklace here that you're talking about? And is this the ruby? Or is this the ruby? Yeah. So you're right, okay, and you know, the human brain struggles to see some regular patterns amid chaos, and so it's that process called pareidolia, which is why you see bunnies in the clouds. Certainly there's no bunnies in the clouds, but your mind builds them in the absence of anything else that it can do it, like the face on Mars. People saw the face on Mars. I looked at it and I see what they see by the face, but it's not symmetric. If you look at the other side, it isn't symmetric. It's not at all symmetric, but your brain forces you to think it's symmetric. When you take a hard look at it, it's not symmetric, and so it's not really a face.
Yeah, that was supposedly a defense thing to see leopards or tigers hiding in the trees, or hiding in the bush.
That's right. That's right. When we were actually looking for predators, they were looking for us.
Right.
Exactly. I got you. All right.
Again, just please.
Yeah, go ahead. So our temperature is still -10. We're still doing well. This is starting to look pretty nice. Look how it's smoothing out over here. You can actually see these tendrils reaching out over the bright nebula. That's not bad at all. I actually don't know what this song is. I was trying to look up what it is. It is called Midnight Special. That's right. Tara must recognize that. This one's called Don't Hate Me. It's actually kind of nice. I like the beat. Of course, go figure, percussionist, right? Drummer.
Hold on, girl, now wait just a minute. I've got something to say. You should hear it. Oh, I'm happy to make time for your feelings, but you have to admit.
Raymond, I'm not sure what you're saying.
Let's just break it down to you and me uptown, dancing all around till the disco ball pops. But I have to be me.
Yeah, this is getting better and better. We've stacked only 17. And this diffuse nebula is just beautiful. This is the colors of the universe, folks. The colors of the universe. Colors of the universe are just stunning, without a doubt. Wow. Hey, hey.
This is just, God, I mean, you could do a sky survey with this thing.
Yeah, I know.
The wide field of depth, too. I mean, you know, you just change field and you got whole new things to look at.
That's right. I moved it, Raymond. Raymond suggested that maybe the sponsor text was covering this object and you couldn't really tell what was going on, so this makes it easier. All right. Yeah. It's pretty cool. I like the difference in the red tonalities here. This is very, very this is very, very characteristic of the universe, is to have these different levels of hydrogen alpha involvement, you know, and this is exactly one of those cases. This is a very intense area, and it's being exposed for just as long as these, but these are more broad, solid, more broad and distended outward than this. This is a concentrated focus object, and it's got dark nebula associated with it, as do these. You can see it. This is dark nebula here as well. That's blocking what's behind it too. And in some cases, there are actual voids in the stars. So that's something else to consider. So 22 stacked at this point, 23 stacked, and we're getting rid of much of the issues here. Let me see if we can actually grab some processing changes here. A little bit of the black level goes down. Let's see what that does.
Mark Donald says you need to go back to this one when you get back from Arizona.
Yeah, we absolutely do.
This is a really interesting composition. Just a combination of so much going on.
I know.
Star clouds and dark nebulosity and
yeah,
the bright nebulosity and the dim nebulosity
yep.
and star trains and all sorts of things happening all at once.
I'm gonna brighten this up a little bit here because I want to level the playing field, make the stars less obtrusive. See, that makes it look really cool now. You actually can see a lot going on here. Very cool. Now, to see what else is here, we can let's hyper process this too. Watch this now. If we do this, let's see what more there is here that's hiding in the background. All right, see that? That's actually hiding back there. A lot more stuff. This stretches up there. Now, if we leave that hyper process on, we can then come over here and grab this guy and take the midtones down just a little and allow us to kind of bring it back to something that we can use, just to study a little better. See that? So now we see the overall composition. We can also just come back and take this off. All right. And that's what we've been seeing for the last little while. A little, almost, not quite. But we can actually come over here and now just take and slide and you know, intercept more of the data and make this data brighter. Okay, that's a little too much, I would say. Just back here was perfect. So there you go. That looks pretty cool. James Dugan from Down Under, how are you? James Dugan is from Australia. And James, we were talking about didgeridoos and the Aboriginals, indigenous, because I learned didgeridoo. For years, I played didgeridoo, and I really like it. It's also known more formally as a yadarki, and I really enjoy playing that. I've got a bunch of them here, and I make them. I make them out of PVC pipe. I make them out of metal fence posts. The PVC aisle at Home Depot is my didgeridoo aisle. Okay, it really is. Yes, weird guy. My God, it's full of stars. Exactly. This is just beautiful. Okay, we have done 30 stacked images for this, and I think that's good. So we're going to pause this right now, and we're going to save it just like you see it. We're going to save the stack. Just save the stack. That little green line, that green thing tells you. Thanks, Ray. Thank you very much. And now we're going to save exactly as we see it on the screen here. So you can actually take the stack, or you can take the exactly seen image here when it goes up to the server, and you can enjoy that. So those are all things that I would like you to do. Thank you very much, Raymond. Okay, so now we're going to clear this and go to a different object. I don't really want to leave it. It's really a pretty object, but, you know.
For sure.
And I knew that there was more hiding in that area than I wanted to see before, so I'm glad we did it. Okay, so now let's do our finder mode, and let's go back to our planetarium, and let's sift upwards into the northern reaches of Cygnus here. And let's just check it out. I mean, no journey would be complete without going to North America Nebula. But we're gonna check out. See, we got the crescent. We can just do a shot of the crescent here, just to give. Thank you, Raymond. We're gonna go with this star right here, because this star right here will take us to this location. So here we go. Telescope will move a little bit. You probably won't see it because it's gonna move more vertically than horizontally, but it's moving. And it's gonna probably go to Saturn right here, and it is. Thank you for the icing on the cake there, Raymond. Saturn is the Gamma Cygni, as I said. And hey, D. Smith, how you doing? I didn't see you here. Sorry, I missed your arrival. I apologize. And so it's going to center solder, and then it's going to take us right where this cursor is. We're going to have this tiny star momentarily. That's right. Okay. All right. So if we come back here, you see the Crescent Nebula, and it looks like it's backwards, and that's because the telescope is, it's like you're looking up and you turn up your head so much that your head is past the zenith, and now you're looking back. And so that flips things on the telescope. That's why it's looking this way to you. Okay, but if you spun around and looked at the other way, well, then it's on the other side and it's flipped. And that's what we've got going on here. Okay, so,
It's getting over in the west now, too.
yeah, it is just a bit. But so here's what we're going to do. We're going to bring the crescent into view, and what you see in there is not the end of the nebula at all, okay? But I'm going to bring the crescent over this way and move the telescope. Which way do I have to go with the telescope? Let me just look. I want to head to the upper left, I think. Okay, so I'm there. Yeah, I do. I want to go to the upper left. So I'm going to move the telescope this way a little bit. Okay. A little bit more. All right. I will tell you, Isabella. I'll tell you in a moment.
Satellite.
You got it. Watch the satellite. Yeah. It's pretty dim, actually. It's you can't see that with your eye at all. Okay. Once that goes, I will set up and do what we want to do here and take pictures. But for now, this is where we are. Alright, okay, now let's do a really cool image. If we're lucky, it's going to look the same as this other image we just looked at. So let's hope it does. We'll do 25 seconds. And get rid of our hyper processing right now. We'll come back to it though.
Isabella says I'm quiet. Do I sound quiet?
Maybe, I don't know.
Testing. 1, 2, 3. Testing.
Well, just bring the microphone closer, that's all.
Okay. Careful what you ask for.
See, you're louder now. That's good. Just in time for our first view of the crescent. Watch this. Look at that. Oh.
There's another one right there. Just the composition of it, you know, the
Yes.
crescent there, and then the other stuff going on above it.
Wow. I think that's... See, I knew this. I was hoping this would be a nice composition. It really looks pretty.
Yeah.
Look at that,
That's
folks. Look at that. Again, the modeling and noise is going to go away soon as we get more, data. That's gorgeous.
That is a nice picture.
I am really glad that we decided to do this kind of run tonight. Kind of off the beaten path. Check out things that are a little bit, a little bit off the path that we've seen before. I like it. Prow says there's so many satellites. You've caught satellites while gazing at my binoculars. Yeah, that's true. Well, think about this. To catch satellites in a telescope that's actually a more of a magnified view should be pretty odd, but there's so many pieces of space junk up there that it's just, there's no knowing, there's no knowing when they're going to come in. Yes, I can go to calculate them, and I can figure out when they're going to show up, but that's a lot of work. I think we can just take a few photos and then be done with it when we're done. And then just be happy that if we get a shot. Like this right now, this is a stack of 5 so far. This down here, this is the Crescent Nebula. Look at that, how beautiful that looks. Just nice structure there, Daryl.
Yes.
The Crescent Nebula. Go ahead.
No, I'm sorry. It's another very nice composition.
It really is beautiful. Yeah. The Crescent Nebula is a nebula that's caused by this star right here. Okay, this is a Wolf-Rayet star, very hot star. It blows off its outer envelope of hydrogen gas, which is kind of like suicide, basically, because if that hydrogen gas could ever migrate to the core, it could be used for fusion. All right, but nevertheless, that's what it does, and the star is going to supernova sometime in the next, who knows, 10,000 to 100,000 years, maybe a million years, but probably not that long. And this is already in the latter stages of its life. When you see it, something like this, the star's already going through a troublesome period. It's near the end of its life. Thanks, Raymond. It's really pretty. You were going to say something, Daryl. I didn't mean to cut you off.
No matter. I don't remember.
Okay. Look at this. This is now even more visible. This you can see this whole area coming in that goes like this. But also notice this line of stars. It almost looks artificial, doesn't it? See all those stars?
Oh yeah. It makes me wonder whenever I see them.
Yeah. Is it actually artificial? Not artificial, but in my case, I would think, did a supernova set off a chain reaction of star formation as its shockwave moved out? That's what I think.
Well, you're in the right part of the sky for it.
Yeah, that's for sure.
I mean, I've heard that when you look up at Cygnus, you're looking at the next spiral arm over. I don't know if that's true or not, but
it is.
You know, you're looking at spiral arm kind of stuff.
Yeah.
There's just so much in there.
It's exactly what we're looking at. We are at a different spiral arm.
The veil's just a little off to the side from where we are too, isn't it?
Yeah. Actually, yeah, we're near Solder, and it's just a little bit west of us.
Mm.
We can go there after, but I'm really liking these compositions. These are just beautiful. This is almost like works of art, pieces of art.
Oh yeah, I dig it. You know, we've looked at the veil 1,000 times, but you know, if you want to do it, sure. I just liked the whole serendipity of this tonight. You know, we're just trolling along the spiral arm and the Great Rift and seeing what lands in the what lands on the camera.
Yeah. Donald Kunzer asks, Mark, can you program to drop frames that have streaks? Actually, there is a process to do that, but I don't know how to do that yet in this system. I could, I think, do that, but I'm not sure. But normally what I do is actually I will not usually do a stack like this. Normally what I do is I take separate files and I stack them myself. But that's no fun for you guys. So this is what I do now. I stack them, like this, so you can see them. Gosh, I'm telling you, this crescent is the best I've ever seen it. Man, look at that. It really is nice. Wow. Let me just go in here for a minute and actually, let me go back to our camera control and let me see what happens now that we have this many frames. Let's do a hyper process of this and see what more is hiding here. I think you'll be surprised.
Donald, it is getting to the point that professional astronomy is being hindered by the number of satellites in the sky.
That's exactly right.
Running data acquisition.
Yeah. But Elon Musk's Starlink process is gonna definitely cause problems. It's causing problems for us now. Several of the satellites that you saw tonight were Starlink satellites that went through, for sure. But we need Starlink in order to have internet out in the observatory. Right now we're using satellite internet, which is called Viasat. And if you notice, when I click on something, I literally have to wait 1 full second for the click to register, because it takes time for it to go from my mouse up to the cloud, up to the satellite, down to the observatory. When Starlink is in play, that time is going to be, it's called latency. That time is going to be down to very, 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 very short time. And it'll be almost instantaneous for us, so we'll be able to do it that way. Cypher's back. Hey, Cypher 2, what's going on? Oh, he said the first time he saw the word serendipity was in a book by Kip Thorne called Black Holes and Time Warps. Yeah. I told the story before. I sat with Kip Thorne, and we talked black holes one time, and he was actually engaged in a little bit of a back and forth with Stephen Hawking about the ability to do time travel effectively with black holes. And he basically said there's a condition by which you can go into a black hole but see your ship emerging from the complementary white hole before you actually go into the black hole. And that was sort of like a time slip type thing. Hawking said, no, that's impossible, Kip. And Kip said, no, it isn't. I'll send you my argument. And Hawking said, I'll send you my argument. And he sent his argument to Kip, and Kip sent his argument to Hawking. And when they read each other's arguments, Hawking said, you're right, Kip. It does work. But then Kip said, actually, it doesn't work. You're right. So they swapped positions. And that what that shows you is that even the greatest minds that we have today, and Kip Thorne is arguably one of the best astrophysicists on the planet, and Stephen Hawking was one of the best, if not the best. It shows you that even the greatest minds sometimes can't agree, and sometimes we see that, you know, there's a lot we don't understand, and it's blatant, and this is one of those cases.
Kip Thorne was the tech expert on the movie Interstellar, was he not?
He was. That's why the black hole in Interstellar looked so correct. Because that was designed, that was made before we actually imaged the black hole, you know that?
Yes.
And so, but it was correct. And what we saw with the black hole in constellation of Virgo, M87, which we'll look at some point, that was exactly what we saw, you know, from what Einstein predicted to what Kip Thorne showed in Interstellar to what we actually imaged. Identical.
You know, me and star trains and stuff, if you look over at the far left edge, maybe a third of the way up, there is a squiggly black line, dark nebulosity, I assume.
On the far left?
Yeah, down a little bit, right there.
Okay.
And if you keep following that, see, it looks almost like a snake.
Yeah.
And there are lines of stars outlining that dark snake.
Well, it could be the dark snake is silhouetting the stars enough so that you don't see other stars through it. And so you're seeing the edge of the snake and illuminated by stars because there's so many.
It's interesting to me.
It is. Well, this one's very interesting. This composition is really cool because we actually have a more solid emission nebula over here, a diffuse nebula here, star cloud, and a Wolf-Rayet star that will be going supernova soon. This is a beautiful image, man. This is nice. We have 27 stacked. We'll go to 30, and then we'll call it for this image. My gosh.
Donald Kunzer says he wishes he could see Cygnus X1. Now, I know Cygnus X1 is a black hole, but it is a double system, I believe, and I wonder if you could see the other star.
I wonder.
Not that it would mean much if we were to look at it. And yes, Donald, Farewell to Kings, that's my favorite Rush album.
And Isabella, thank you, but you're coming along very nicely, so don't you second guess yourself. She basically says that she likes how I process stuff. Well, you know what? You're doing very well yourself. Okay, we're at 29. Yeah, we're going to stop at 30 here. We're almost done. We're halfway through, 3/4 of the way through. This represents...
Make a great image.
It will. This represents our data. Wouldn't it be funny if it's a satellite that we see? Okay, so we're going to pause it right now. Awesome, we got through it. Okay, so we're going to save this. I will be, of course, making this available to all of you, of course. So the FITS file stack is now saved, and we're going to save it exactly as seen. So when it's up there on the server, you can just go grab it and enjoy it all you want. All right. But that was perfect. All right. And so what we looked at, of course, what we saw was this right here. We saw the region near the Crescent Nebula in the Cygnus Milky Way. And I think that is just a beautiful object. So now what we're going to do is go back to a 1-second finder scope setup here. I call it a finder, but it's not really a finder. But it's worth doing because we can see everything that we're doing. Oh, I got to get rid of that. No, I don't. Okay. Okay, this modeling is because the internet is slow right now. All right, and let's go down to our... I think I want to do one more object, and I'm going to pop out of this a little bit and just give in. I'm just going to give in and do this because this is by far the most beautiful object that we can see in the summer sky besides the Lagoon Nebula, which now has almost set. So we're going to go here. We're going to go to Deneb, this star here with the finder. The telescope's going to go to Deneb first and use that as a stop off, and then use it to actually then make its way to this star here. And there is Deneb. You'll see it there. You ask, well, how do you know what star it's going to use? I don't, but over time, I know how the telescope works. Yeah, Raymond, what happened? Raymond says, I just got shut out of your stream. Holy moly. But I'm back. Good. We don't want you to go far, Raymond. Thanks, Donald. I'm glad you're enjoying the views tonight.
Raymond has that not so refreshed feeling.
Yes, that's right. That's right. Okay. So we are lining up on what is known as the North America Nebula. Okay. And so let me take us down.
I see the Gulf of Mexico.
Yes, you do. And now we're going to move a little bit to the east.
You see the top of the Pelican's Head, the back of it.
It's right there, yeah.
I see the Cygnus Wall.
Yep. Okay. That's this
I
right
see
here.
Florida. Yep.
That's Florida. Yeah. All right, so we're going to move over just enough to actually keep the Pelican in the view and the Cygnus Wall in the view. All right. I think that should work. Shall we try it? Yes, we shall. Okay. Telescope takes 11 seconds to acquire a guide star. That's what it's doing now as I'm doing all these other things. And we're going to go and we're going to do 35 seconds on this right now. You know? Actually, I'm going to try something crazy. I'm going to do 50 seconds. I want to see how it guides at 50 seconds. Oh boy. Let's try that. And now we come down here, and you'll see the counter go up a little slower this time. But let's see how it looks. Let's see how 50 seconds looks. I bet you it's going to be really, really bright. You know. You see Florida. I see France. I see so-and-so's underpants. Yes, Tara, I know. Raymond knows, too. That's cool.
Well,
Doodah.
I, for one, I'm going commando tonight, so there.
Oh, that's so much more information that I needed to know.
Yeah.
Oh. Well, let's see what our 50-second shot looks like. Let's see if the stars are going to align or if I need to do some... Oh! It works. Definitely works. Looks like a painting.
I see the Cygnus Wall is happy to see me tonight.
That's correct. What am I going to do with you? Let's just...
I don't know.
Let's do that. Let's bring that out. So now, that's a exposure of almost a minute. It's 50 seconds. That is just beautiful. Now the color's not quite right. The nebula should be a little more red. It shouldn't be this yellowish, weak yellow with the green. So we are going to try. Yes, look at all this dark nebula in here. It almost looks like just somebody scraped this Pelican Nebula. But when you do longer exposures like this, you actually see more texture in the nebula, and that's why I wanted to do it. I wanted to make sure we could see it. And again, we have 2 stacked right now, so this is good.
Sorry.
What were you laughing at? What did I miss?
Conversation in chat.
Oh. Well, I'm looking in chat. I mean, you talking about click clack?
All of it.
Oh,
I should go to Bad Bear Corner, I guess.
Oh, okay. See, you took our chat right down the off-color parkway, didn't you?
Oh, well.
I know. Let's maximize this so at least people can have a good time. Let me get my head out of here. Now we can look at it this way, see? I mean, look at that. Oh, that's beautiful. Wow. That's something else. Now, see, this is the thing. I don't know if there's any other observatories out there that actually do this kind of immediate satisfaction stuff where you can see this like this. I don't know that there's any others doing this. I mean, it's probably true, but man, look at this. DK, we'll see you later. Wow. That's just amazing. You notice when you look at this, look at the back of the pelican's head up here, right there. Okay, the back of the pelican's head is actually a little more red, and then you see this right here. It almost looks like it's being lit by a light, right?
Yes.
Well, you got to keep in mind that what we're actually looking at is more ionized gas there. And it's the ionized gas that's making its own light. It's not reflecting light, it's making its own light from the ionized gas. And there's probably black dust over this gas that makes it less visible or less red, or it gets thicker. So that happens too. Look at this tangle here. Look at this amazing tangle of black here. This is crazy.
I seem to remember hearing that Deneb is what is energizing the clouds.
Yeah, we talked about that, and I'm actually not. I'm not sure. I mean, if you go and look at the distance to Deneb, because the distance to the North American Nebula is 1,500 light years, right? Something like that.
Okay.
And the distance here is to Deneb, it's given in this example is 1,400 light years. And if we go to the North American Nebula, its distance is given as almost 2,000 light years, 1,892. That's well within reason for energizing and causing this. And also, if we look at Deneb, what kind of star it is, right? Deneb's not a star like the Sun. It's a supergiant. It's an A2, which is a very hot star. It's a significant ultraviolet. Not as much as a B star, which is brighter before it, or an O star, which is even brighter, like the biggest stars in the universe. But it's a Roman numeral 1A. If you notice this right here, it says A2 1A. Okay, so it's a very early A, as we call it, and it's a 1A. This 1A means it's a supergiant. So, as an A2 1A, it's not a red giant. Okay, so as a supergiant star that's an A2, it means that it is a massive, massive star throwing out a lot of ultraviolet energy, and it could very well be energizing this region.
If you look at the stellarium image there,
Sorry.
The very red part in the stellarium,
The pelican is the
yeah,
closest
that right
thing
there. I mean, that's the back of the pelican's head right there,
Yeah.
which is shining the brightest. Now, we're just looking at a 2D representation here,
Right.
but still, make you wonder.
Well, then the Cygnus Waldo is also glowing bright down here.
But,
And what's causing that? It's probably not Zeta Cygni here, okay? Because that star is it's a K, and it's a Roman numeral 2 luminosity class, so that's a giant, but it's not a 1A or a 1B. It's a massive star, but it's certainly not a star that is probably capable of illuminating a lot or doing a lot of ultraviolet. K stars typically are cooler in temperature. They're actually cooler on their surfaces than the Sun. And the Sun doesn't do a lot of that because they come after us. It's O, B, A, F, G, K. We're G. We're a G25, a G2V, Roman numeral 5. Which means that we're a normal star doing normal things.
and this one is 842 light years away.
Right, which is way in the foreground compared to the
Yeah.
distance. So it's not doing anything. Wow. 9 stacked frames here, guys, and it's really coming out beautiful. The guiding is just spot on. Look at how tiny. Look at the fringe in here. See this fringy look in here? That's beautiful. Wow. Here's something I haven't seen ever. Right here, there's a bright object in here, a bright line. See that? I've never seen that before. Thanks, Raymond. You're right, the drinks are probably $5 at this point. Look at that, though. You see that, Daryl? There's that bright little line. I've never seen that before.
Yeah.
Yeah. I would say if this part of the Pelican is closest to Deneb, that would explain why we're seeing this. This stuff could be on the lee side, the other side, and thus not have as much exposure to it. But it is a diffuse nebula. It is glowing red. It's just not as intense as the backside.
And there's nothing to say the Cygnus wall there.
Which is this here.
Yeah. Try to visualize that in 3 dimensions. That who's to say that's really much farther away from Deneb than the back of the Pelican's head is?
Yeah, because you're seeing it in 3D, so you don't know exactly. I mean, it's hard to think that this and this could be close to each other in space, but they could be. Raymond, thank you. Thank you again. Yeah, so these could be relatively close in space, but you have to understand the spatial relationship. You're seeing them this way, but in reality, they actually could be relatively the same distance from Deneb each. Because Deneb could be on this side of them or on that side of them, and the Pelican could be here versus the other part there. There's this whole North America complex could be closer to us. I actually think that these two are part of the same cloud, that this is separating and making it look like it's a separate thing, but this is a dark nebula that is just bisecting a bright cloud, and thus it's in front of this one general cloud. So these are probably the same distance from each other, but there's no one saying that this might not be. This could be all warped. This could be warped upward, and this warped downward. See, if you look at that from the side, we think as we're looking at it this way, but what if we're looking at it like this? You know?
Yeah. Interesting to contemplate. I have seen 3D representations, animations of like the Orion Nebula, for instance. Yeah. You've probably seen it.
I have.
I wonder, it'd be interesting to see one of this area.
Oh, I agree. I'd love to see that. Actually, I'd like to acquire the data to do it. I'd love to do that. And what we need to do is get the distances to these different cloud elements. Yeah. But good luck with that. Wait, isn't this beautiful, guys? This is just really pretty. I'm really liking this. And look at this here. When have we ever seen these streaks in the Pelican before? A 50-second exposure is showing us a lot more detail, huh? Yeah. I really would like to go to like 2 minutes and see what we get, but we'd probably overexpose all this. Maybe up here we'd overexpose. But don't worry, we're going to be doing this again. We'll be doing this again. Okay, this should be the 15th, and we'll stop with that.
Thank you, Raymond.
Raymond, thank you. Raymond, you're earning your wrench. Wow. This is majestic, and sounds like a really majestic song for this nebula. Okay, we're gonna do 16 and then stop. Okay.
Donald Kensler sees Deadpool's head there just to the left of the Pelican's eyes.
What, in here?
Yes. That oval area in the dark spot. You were pointing right at.
Right here, yeah.
No, a little bit to the right of that.
Oh, here?
That right there.
Okay.
That oval of the two dark blobs and the stars in each other.
Yeah, that's true. Wow. Okay. Well, we better save this before we can't for some reason. So save. Here I am thinking I was going to make a shorter stream tonight. We're already at 3 hours. But look at what we're looking at. I mean, we're seeing some really, really interesting stuff. And Orion's not even up yet. Orion's going to be fantabulous. Did I say fantastic or fantabulous? I think I said fantabulous. Yeah. Okay,
You did.
we're gonna clear this. After one more look, you guys get one more look. Look at that. Beautiful detail in here. So, I mean, look at that. Now you see wispiness in here. Holy cow, look at that. There's wisps in there I have never seen before. Wow. Wow. Outstanding. All right. So now we're gonna come out of this. I really hate clearing it. It's just so beautiful, but I know we saved it, so we got it. And now we'll do our. It'll be up on the server after the apparently the internet. And by the way, it doesn't get lost. Okay, if you think it's gonna get lost, it's actually saved on the local machine in the observatory. It's not going away. It's there. Okay. And so, if for some reason it doesn't get to the server, it has not been lost. It is saved on the server, on this machine. Perfectly fine. Okay, let's do this. Never knew there was so much there, did you? But there is. Okay, let's go here. As we're moving northward, let's see what else there is. And we didn't even get to Cephas tonight. You know.
Somebody asked about the coal sack earlier. You want to look at the northern coal sack right there?
Yeah,
Very close to it.
We can. Where is that?
Just to
Oh,
the
right here.
lower
There it
left
is, yep.
of
I see.
where you're pointing. And you got the funnel cloud nebula too. Maybe that's another dark nebula.
Maybe. Well, actually, since our telescope is relatively aligned, I might as well just steer us there. Let me get us out to the telescope view here. So we're going to opt out of the full screen, bring up our digital planetarium, and we need to go to the east, I believe, a little bit. I guess we're going to go to our other east. My mistake for... Okay, so we're going to come down here. I think the coal sack is way bigger than... I think it's way bigger than our field of view. Okay, then we can go south. Okay. Alright, technically we're at the coal sack, but doesn't look like it yet. But I think a nice deep exposure will prove us one way or the other, right? Yes, it will. Alright, so let's just center it up. Alright, here we go. Let's go check it out. We'll go into the coal sack. Northern coal sack. And it's exactly what it sounds like. It's a please do that. Please thumbs up. It actually is a very nice region. It's going to be dark nebula for sure. We'll do 40 seconds on this. Just not to spend too much time on it, because I have a feeling I know what we're going to see. But I could be wrong. I could be wrong. Okay, we're going to live stack this again. And we're going to clear this image because we don't want that. Okay, we cleared the stack. And let's see what we got.
Excuse me.
No problem. And the verdict is processing required. Now let's see who he is. Oh. That's interesting. Oh. Right. So that's where we are. Okay.
Yeah, it's good. It's not great.
Yeah, I agree. So I'm going to.
I just wondered since we were in the neighborhood.
Yeah.
And somebody had asked about the coal sack earlier.
Okay.
Maybe-
Probably the southern hemisphere coal sack.
Yeah, that's what I said at the time.
Yeah. So we're going to pause this. Clear it. And we're not going to save this. We have plenty of saved beauties. Right, down by Crux, as Daryl just said, yeah. We're going to go to 1 second again. And we'll go back in here. And let's... So we're in between beautiful objects. So let's go past where we just were. I'm not going to do the elephant's trunk tonight. I want to do something we haven't seen before.
I know we looked at the Cave Nebula last night in
Yeah, we did.
CBS.
Yeah, we did.
Did we look at the Wolf Cave Nebula?
Don't think so. Where's that?
Give me a second.
Maybe I can find it if it's in Stellaria. Does it have an NGC, an IC number?
Yeah, give me just a moment.
Okay. Maybe the Dark Wolf Nebula? Nope. It is pointing elsewhere. Okay.
I'm looking at that list. Bear with me, please.
I will beareth with you, my good man. Yes. Bearing with you.
How about the Wizard?
We can do that
I
again.
know we have done it before.
That's okay. Well, we have not actually looked at the Funnel Cloud Nebula, have we?
I don't remember. I don't think so.
Well, we're going to go to the Funnel Cloud. And then we'll go to the Wizard or something else.
We did try the Ghost Nebula and it didn't show up much, did it?
No, only because it was small. Now we're at Deneb again. Alpha Cygni,
Okay.
the brightest star in the constellation of the Swan, Cygnus the Swan.
The Wolf's Cave. You want to go ahead and try this one?
Yes, after we get to this, wait, we do this, you find it? Does it have an NGC number?
Not an NGC that I know of, but
An IC? Like index catalog? Sharpless?
VDB 152
Vandenberg, okay.
or CED 201.
Okay. Well, there's something here. In the funnel cloud, there's something here. All right. I will try it just like. Well, actually, you know what? I'm gonna do this. I'm gonna get out of the screen here just to. All right. And what I'll do now is I'm gonna move us a little south. Okay, that's a little more, and then I'll take the picture and see what we got. There's so much stuff here.
Which one is this?
The funnel cloud.
Ah, okay.
I'm actually gonna just take it like this because I don't know what to expect here. This will be a 45-second photo as well. And then we're going to pop out of our hyper process and go into our live stack. Okay. 45 seconds. Get your stuff together. Here it comes. What do we got? Is it worth it? Nice dark nebula there.
Does that brightest star thing left of center, that look green to you? That right there?
No.
Okay.
It looks blue. I'd like to abandon this object.
Okay.
Yeah, this not doing it for me.
Try the wizard then.
Yeah, we could go to the whiz. Okay, so let's do this. Let's do this. I knew it said 11. I didn't want to do that. Okay, 1 second. And do that. And then for the stack. Get rid of that. And bring us back to this. I went back to my room. Alright. So, when Auriga comes up, guys, there's a beautiful nebula in there that's blue and red. It is positively magnificent. It's called the Flaming Star Nebula. I can't wait to spring that on you guys. It's beautiful. Okay, the telescope is going to the star. Oh, you can't see it because it's doing this. Well, either way, it's putting that star in the center. And then the Wizard Nebula will be right here in the middle. You mean the Running Man Nebula, Isabella? I don't know the Running Chicken Nebula.
James says it's down by Crux in the coal sack.
There's a Running Chicken Nebula?
I believe it.
Boy, James, you guys in the South really do have weird names for your stuff. Of course, I'm kidding because we've seen plenty of that. Okay, that's perfect. Alright, we're going to do 40 seconds. And without our hyper processing, we're going to head into the stack. This is the Wizard Nebula. It's a nebula that, again, is a diffuse nebula with star formation going on.
If I remember right, this is the one I could see the wizard on the left, and I saw a figure of like a little girl holding her hands out toward the wizard on the right.
I think you might be right. Could be. All right, let's see. Let's go into this here. Ah, look at that. That's beautiful. Many stars, folks. Many stars.
Maybe I saw that in the APOD picture.
Huh. You can see many streams of black dust filaments.
Yeah, well, this is the one I called it spider legs.
That's right.
All the dark lines.
Yep.
Lanes, whatever.
Hmm.
Like the body of the spider is the big dark blob up at the top, and the dark lanes radiating out from it on either side.
This way.
Especially toward the right, remind me of spider legs.
Yeah. And this is the fly it caught in its fangs. Wow. This is just incredible. So you see, this is kind of what you get with SkyTour LiveStream, guys, you know? We see the wonders of the universe. And it's just amazing. And Ronald, oh, plane, look at that. Ronald asks, is there a Tarantella Nebula?
There's a tarantula.
That's what he's trying to say. There is a Tarantula Nebula. Our image was ruined by this plane. And by the way, the belly strobe on the plane actually went off right at that time. We have the red lights and the green, right? And the plane, of course, was actually heading from upper left to lower right. At least it looked that way. It might actually go from lower right to upper left, actually. All right. Well, we gotta eliminate this. We're gonna clear this because we don't want airplanes. And I'm gonna pause it because there's got to be something else that I want to see before we close down for the night. And I'm gonna try and find it. Okay, we're gonna get rid of this. All right. All right, now let's go over here. Here's another little gem in the making right here. Here's a little gem in the making. This is what I want to see. See, we did NGC 7822 yesterday, which is this guy over here. And I have images of that to show you. Well, while we're looking for this, I always want to make sure that I have eyes in the telescope, so I'm going to pop out of this. I know we're good for now, but Cassiopeia is high in the sky, as high overhead as it can probably get down in Arizona right now. So we're doing okay.
Yeah, Cassiopeia is actually in the western sky before midnight now.
Yeah. Thought we had a satellite coming through while we moved. So we've seen about 6 satellites tonight so far that just popped through. But it's this little nebula that I want to image and see what's there. I think this is going to be a little more extensive than we realize. The other thing I want to look at is the Gamma Cast Nebula. We'll do that next time. Alright, so right now the telescope is capturing a guide star, and it's going to use that to guide on as we set up our time here. We'll go and we'll do 30 seconds on this one. Because I'm not sure.
What are we looking at now?
I don't know yet. It's just a region in Cassiopeia that has nebulous detail, and that's what we'll call it. Yeah.
Well, that's interesting.
Yeah.
You don't know what that is?
It looks like the cave almost. But I don't think it is. I could be wrong. Did I just bring us to the cave again? I did, because aren't these those stars? I might have just brought us to the cave. That's okay. I did. That's the Cave Nebula.
No.
That's alright. Let me bring up my... Actually, now that I know that... Okay, here's what we're going to do. I'm going to try something crazy nuts. Let's do a 70-second exposure in here and see if it works, okay? So we're going to go back into the stack, and we're going to clear everything so we can see it from scratch. Now, for those of you that think that's a long time, I can tell you, I've taken exposures that are hours long, so it really isn't a long time for me, but it is a long time for someone who's watching in a stream. I get it. So I'm not going to do too many of these. I just want to see what it looks like in 70 seconds. Because I processed the cave and I didn't see enough detail that I was comfortable with. So I'm going to do a couple of these and see if it looks a little better. And if it does, I'll come back privately and take maybe 20 at 70 seconds or even 2-minute shots or something, just to see what we get.
Remember when we tried to see the squid and the flying bat last night?
Yes.
I read later that that guy, when he captured the squid, he had 55 hours of exposure to catch that.
I believe it.
So, shame on me for asking you to go look for it.
Oh, it's okay. I see that I probably should have moved this up, huh? Yep. But let's see what we got. Let's see what we got. Wow. That looks pretty good.
Mm-hmm.
Oh, I hate to do this to you guys. But I'm going to actually... I'm going to do this. I'm going to... Arg. Okay. 1 second. And we're going to get rid of the stack. And we'll bring it back in a moment. And I'm going to go down a little bit, bring this up. Just a little more. I didn't do it that much. That's too much. Sorry, it's that 1 second delay. Okay, let's just bring this down again. There we go. That looks like it'll be good. All right, so let's go back and first let me change this and go to that. All right, that's pretty good. Okay, and now we're gonna do this again. And by golly, I can't believe I'm doing this, but I'm making it a 90-second shot. A minute and a half. Oh boy.
You're insane.
I'm insane. I'm going to lose our whole audience because they're going to say, what are you doing? I don't want to see this for 90 seconds. So, I just want to see what's going on. I want to see how it's going to look. I just want to see the detail that's going to end up in here. And I predict it's going to be stupendous. Tara says it's so very pretty. It is. It's really pretty. Raymond, what's the issue? Someone's controlling typing? No, no one's controlling typing. I won't hear of it. People get to say what they want here. I think Raymond was trying to say something else. Look, we're almost done with our 90-second shot. I'm pretty excited about this. Let's hope it looks beautiful. Let's hope that the guiding is good. Because I haven't even tuned the guider for tonight. Let's see if it even comes close. Wow, it did. It did work. Okay, let's now go back into our stack and let's process this a little bit just to see what happens when we darken it up. Okay. Oh my. Oh, look at that. That is so much nicer than the other night, the image I took. Of course, it's also went from a 20-second exposure or a 30-second exposure to 90 seconds. Holy cow. Well, that's funny. Letting Ron say what he wants sounds like a bad idea. Oh, that's funny. Okay, we're almost done with the second one here. Let's see how this works. This is an area of star formation that's going on here. And this is all a diffuse nebula with dark nebula intermingled. You can clearly see it here. It's really, really beautiful. Oh. Okay, we have two stacked now. All this noise is going to go away over the next few minutes here. Isabella, this is a magnificent nebula. I hope no planes go through it. This object down here that you see right there is, and if I don't miss Daryl mentioned it the other night, but I think that this object is called a Herbig-Haro object.
Yeah.
And that is another very energetic location within this nebula. Okay, we've stacked 2. We're still climbing to 3. We haven't lost any. I mean, we can do much better than this, just for the processing here. We can do a little better. Let's
almost softer than the image last night was.
well, that's because it's got more data. So if we want to get it to look a little bit better, then we kind of bring up the black level like this a little bit. But it's doing what it has to do. I mean, look at this object here. Look at how just beautiful that is. This is stunning. I always say one more object, don't I?
Yeah.
Well, it always happens. It always happens. Wow. Yeah, I don't want to do that now. This is actually more like the real astronomy that gets done. Yet you're probably only like, a fifth of the way. Thank you, Raymond. Thank you very much. What are you talking about there, Ronald?
Wanted to know why everything was red.
Oh, he thought it was helium? No, Ronald, that's why your voice gets high.
This is how you sound on helium.
Wait, what happened?
What?
Oh, man, did I... No, it's not lost. Okay, good.
JSCO 77 asks, what is the bright object in what the bright object is in the right side of the edge of the cave opening?
Oh,
Please, is that just a star?
Well, okay, if you look around this whole edge here, okay, you'll notice that a lot of it is illuminated, or it looks illuminated, and you have more of it over here. So we're seeing a mix of nebula types here. This is dark nebula in here, right? It's really black material that's in here, dark brown material. This is a hydrogen, very, very hot hydrogen emission region. And then we also have a thinner hydrogen emission region that's over here. And so it looks like it's not quite as red, but it might very well be. It's just all... it's a region of hydrogen gas that's been ionized by the hot stars in this area. It's possible that you don't even see the stars that are causing this gas here to glow, because this is dark nebula, and you can see this almost like a three-dimensional blob that's inside that, What? Uh-oh. Live stacking is paused. No way, don't do that to me. Resume. Okay. So yeah. So basically, the bright area then is more of this ionized hydrogen in all likelihood. The same cannot be said for this area here. You notice down here, this area is actually kind of blue around the star. This blue is this star here interacting with the dust that's in this area. If this star wasn't here, you'd see a continuation probably of this dark nebula through here, and you would have seen this as a dark nebula. But because there's a star here, the starlight is hitting that dark granular interstellar dust, And the high frequencies from the starlight are blue light. Blue is short wavelengths, and those are high frequency, and they strike the dust, and the dust takes in that light and throws it back in every single direction, every which way. It's called scattering. The same thing happens in our sky. I've mentioned this yesterday, and that's why our sky is blue, because the high frequency light from our sun, which is blue, it's always blue, high frequency light, is scattered. So in the visible spectrum anyway, that blue light gets scattered like this. And so these nebulae look blue. And they have been called reflection nebulae, but technically that's not exactly what they are. Who has to reboot?
Raymond sounds like he's struggling still with his computer. He left for a second, then he came back, and
Okay.
he says there's too much fluff right now. He can't explain.
Oh, Raymond, I'm sorry, man. What's going on? Well, at least here.
Ronald asks, is the red hydrogen in front of the star field? I dare say it's behind it. It's through it. And,
it's all throughout it. Yeah.
Yeah, it's permeating the whole thing.
Yeah. See this stuff here, Ronald? When you see this stuff here with the dark lines here, okay, this stuff, this is dark dust that's actually in this nebula. And so the nebula that's glowing back here is behind that. It gets behind it, and the dark dust is in front of it, okay? And so this dark dust is obscuring what's behind it, all right? And when you look at this location right here, another thing is the same thing. You notice how many stars you see here all around this? You should see those stars here, but you don't. That's because this here is up in the foreground, blocking all those stars back here that are behind it. So it's really a foreground background thing that you're looking at here, and as such with many nebulae, that's how it looks. That's how it is. I'm just mightily impressed with what I'm seeing here.
We just discovered this one last night, right?
Yeah, well, we discovered that this cave is one we haven't, seen.
Oh.
And Vera Lucia Campos says, Mark, why is it so square? I assume you're talking about this section up here, Vera. You're talking about this right here, this square. Okay, that's happenstance. That's just the way it turned out. It may not be square. In fact, it really isn't. If you notice, this line comes down. This could have been shaped by a shock wave at some point, or a tendril of material that was shot off linearly from a star. And then this could have been shaped by stellar winds over a long period of time. It's not that it's not square. In fact, it comes down. It actually isn't quite square. You see it goes down and then goes up. So not quite square. But and then over the top it looks like it's square here, but it's we don't know what that shape is. It could actually be kind of all convoluted and just looks somewhat square from our direction of viewing. But sometimes we see dark nebulae in these sheets, and the sheets tend to be linear. They're aligned with each other, and sometimes they have what looks like square edges, but that's because of the way that debris, the dust actually is arranged in space. There's no real knowing why or how the dust is why the dust arranges itself in such a way. I don't even know if there's been any studies that have been done to talk about that. That's kind of cool if there was. All right, I'm going to go back to our stack for a second, because one thing I'd like to add is a little bit of a sharpening. So you're going to watch it get sharper now. Okay, look at that. It just sharpened up tremendously. That's called an unsharp mask. It's actually, you'd see it if it wasn't behind me. Okay, so right there now, it's actually sharpened up. I did make it sharpen up. So that's really good. So now it looks even clearer.
That Herbig-Haro object looks a little sharper too.
Yeah, down here.
You know, now I think I see more like what we saw last night, where it looks like there's another dimmer red patch to the left of that Herbicero object.
There is. Yep, right there.
There's and there's a dark cloud almost like it's overlaid between them.
Right there.
Yeah, kind of a peanut shape.
Yep. This is really cool. So we've done 7 frames, but it's actually kind of cool, isn't it? See this, guys? This is really neat. I have to say, this camera does not disappoint. It's a dedicated astronomy camera. For those who want to know what kind of camera it is, it's a ZWO ASI 294 MC Pro. There you go. As a dedicated astronomy camera, it actually it actually gets the job done in a way that is a real credit to the ZWO line of cameras.
I have seen when you, at some point in the process, it may be when you live stack, it lists 2 ZWO cameras.
You're talking about up here. Let me look.
Yeah.
All
Okay. Yeah, and I see which one is live. What is the other ZWO camera? The A9, whatever it says?
It just says ASI.
Oh,
That's actually a label.
all right.
See, Starlight Express cameras, and you have the Superstar M. That's our
I
all
see.
sky direct show cameras, and you got these 2 for and ASCOM cameras, and you got these.
Very good.
Those are
Okay.
just labels.
I thought it was saying you had 2
You know
ZWO cameras.
You're not the only one. I thought so too at one point.
Did you get this camera at the same time you got the Hyperstar
I did.
to help match the pixel size to the
I sure did.
format?
Yep.
Okay, that makes sense. I was reading about that, or not reading, but watching a Hyperstar how-to vid the other day, and they were talking about the importance of selecting pixel size.
Yeah. It keeps buzzing around my head. This white thing keeps buzzing around my head. It won't go away. Hey. Yeah. Yes, I'm playing with you.
Is it real, or
No, it's this right here. See?
I need to look at the YouTube page, I guess?
Oh yeah, you do. Sorry,
Oh, okay.
it's my pointer. See, it's like
Right.
Let me get it. Ah, beep. Dum, 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 dum. This is really pretty. All right, let me. I want to try to do some more processing here. Go to our histogram and process that again. Now we're going to go a little brighter, and let's take the black level over just a bit. So we're shifting a little bit out of the data, but here's what it does. It's going to darken things up a little. Look at that. Wow. Now we can go back to our other view, and let's actually play with this guy. Let's move it all the way and see what we get first. Wow. So now you can see what else is there, and it looks like we've captured almost everything.
Huh.
We've captured almost everything for the cave here. Yep. Got it all. Not bad. Not bad. I mean, very good, in fact. I'm telling you, I'm very happy with this particular image.
Would
This
you
is
like to
10.
still try the other cave nebula?
Oh yeah, you have it?
Yeah. Give me just here.
Okay. We've stacked 10 here. Technically, I should stack many, many more, but I'm going to tell you what. because you want to do the other cave nebula, I'll wait till you tell me where it is so we know.
Well, it's in Cepheus.
Okay.
Blah blah. I have no guarantee how this is going to look.
What's its
It's
size?
the one. It's Vandenberg 152.
Okay.
I don't know if that'll be in your catalogs or not.
Okay. What I'm going to do is I will let this go to get the 11th frame. All right, we're almost there. And then I will be moving on to that.
Okay. We don't have to. We can save it for another night if you want. Actually, I need to go pretty soon.
Don't you do that. You can't go anywhere. If you're going to call out that we got to do this Vandenberg object, you ain't going nowhere. You're stuck here until we see it. Okay.
Who was it I heard say earlier tonight they wanted to stop earlier?
I'm sorry, I don't speak your English.
Yeah.
Okay.
I hear your words, but I do not understand them.
That's right. Okay, alright. I've just saved it exactly as we see it here. And I saved the FITS file, which is the astronomical format. Alright, so I hate to do this, but I gotta just do it. Walk away. Alright. And now let's do this. We're gonna come out because we're moving the telescope. I want to be able to see the telescope and the other things that I need to see. Alright, let's do this. We're gonna go to 1 second. And oops, gotta get rid of this.
We got to the point in looking for dark nebulas and such in Cepheus. Actually, last night that I just did a search in APOD for Cepheus and started looking for objects. In the list it gave that it was starting to repeat itself over time. They tended to keep hitting the same objects.
Okay.
And this is one that I don't think we had covered before, the Wolf Cave Nebula.
What's the identifier?
Oh, just a second.
Oh, I thought you had it already.
What?
I thought you already had it.
Well, again, it's called VDB 152.
Okay, well, let's see if VDB 152 is in here. Otherwise, we're going to have to go find this BD all by ourselves.
Yeah, and also CED 201.
Wait, VDB 152?
VDB 152.
Okay, let's see if it's here.
It
is.
Okay.
So let's find out where we are.
It's at the tip of Barnard 175.
Okay. Ooh. Look at that. There's a nebula there of some kind. Alright. Alright. So. Looks like something is there. I guess we can try it. Let's go there. Probably gonna pick a Alderamin or something like that as a star. Yeah, it's going to where? Donald, I'm hoping that you come back the next time. Thanks, man. Thanks for coming along. We'll see you the next time we do this.
don't know what we're going to see here, if much at all.
Well, you know, that is part of the mystery. I mean, I see the object right there. I see an object right there. So there's something here. But let's bring this up a little bit. There we go. All right. There, see that? It's got a reflection nebula around the star there. And there's something here. There's a little nebula here. So let's go find out. Let's find out what you're sending us off to, Daryl. All right. We'll do 45 seconds to begin with. We're not going to go into the 90s on this one. I don't believe. So let's turn this off. Let's do the live stack and let's clear the stack because I know there's something extra in there. All right.
This is it's a light emission nebula at the end of a dark Barnard object nebula.
Okay.
So we'll see how it translates.
I mean, it could be the coolest thing in the world once we see it. No, I can't wait. And we're just seconds from seeing it. We are 12 seconds from seeing this. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Display the first image, please. Process first.
Well.
Well, wait. Give it a chance. Oh, okay. That's interesting. That's the object, clearly. Better for a longer focal length instrument.
Yeah, could be.
Yeah.
It's actually the dark object is quite long, and if I had to guess, it's moving up toward the top in the image.
It looks like it is.
Yeah. You know, it's a Barnard object, so you want to see it silhouetted.
Mm-hmm.
It's another dark cloud that looks sort of like a fish.
Okay.
And the light object is in the fish's mouth.
Okay.
Its nose.
Well, we'll have to come back and see it another time, probably.
Okay.
That was a nice try.
Sorry.
Oh no, not to worry.
Back to my corner.
No corners. We did good. We did good tonight. This is very good. The Cave Nebula was the highlight of the evening, I think. You know?
Yeah.
Yeah, it was the highlight of the evening. Well, folks, I'll tell you, we had a great night. I really hope that you guys enjoyed. And I want to thank you. Thank you very much. We were going to see you next time. You can stick around if you want to watch the close down procedure of the telescope and everything. But I do believe that we had a really nice night. Lots of really cool stuff. Lots of very, really cool objects that we caught together. I feel like I'm doing it with all of you. It's just a lot of fun. So, step one, I'm going to shut down the planetarium program here and exit out of it. We do these things in the proper order. Okay, so that's gone, and that means, and also my focuser, I never had to use this tonight, which is wonderful, so I can just disconnect and hang up, basically. Now, the Observatory planetarium program that guides the telescope is no longer connected to the telescope. So there we go, that's done. And now the only thing left is to park the scope, and that's what I'm going to do now. You'll watch the scope park itself in a position that we predetermined so that it actually is safe there, and then we can disconnect it. So I think we have everything closed down that we need to. So you watch the stars moving here as we do this. Here we go. So watch the telescope and watch the stars. I still can't believe just how interesting it is that this all works so well from such long distance. The telescope is now in its park position, and there we go. So now I can turn off the power to the pier and the power to the telescope. All right, and so I do that. The telescope is now off. Okay, and I can disconnect the scope here. You're seeing the camera, the sensitive camera, looking at that pinkish view that you're seeing there. You know what that is? You're gonna laugh, but this camera has a little red LED on it, and that red LED is shining the most imperceptibly faint light on the opposite wall of the observatory, but the camera's picking it up. That's how sensitive a camera we're using here. Okay, so we're disconnected there, so we're gonna disconnect this. Okay, and away we go. And now I can shut down this camera and disconnect my camera, and then shut this down. Camera will now warm up, and then I can shut the roof, and the roof you'll see shut here. I'll move it over so you can see it, and bring it up a little bigger. Okay, and now we shut the roof, and there we go. And the roof is now closing on SkyTour LiveStream West for tonight. And we are done. I did write a computer program that runs all this stuff using a microcontroller called Arduino. So it's really kind of cool. Very nice. I want to thank all of you for being here with us. It was a wonderful run and most enjoyable time with all of you. And I look forward to doing this with you again. I always like to do it when there's no moon, but as you know and have seen, I will often stream when we have a moon as well. But
yeah, moon's going to rise in about 15 minutes.
Yep,
Where you are in Arizona.
That's where I close. I close when the moon rises. Because we had a problem with it. Not a problem, but it just gets annoying. Everything works fine.
Well, good night, everybody. Thanks for coming.
Great to see you guys. And I look forward to seeing you on the next SkyTour live stream. And on behalf of Daryl and myself, you guys have a good night. And once again, don't forget, okay? Just give us one of those thumbs up, will you? We can really use those. So give us a thumbs up. You know, subscribe and click that bell if you haven't. And we will see you on the next SkyTour live stream. We'll see you later.